welcome all the delegates in general, Mr. V. Suresh in particular, our chairman, for such an important event. This program has taken 3 months, 4 months in the making. And my team, which is of course headed by Mr. Bhavani Prasadji, Ms. Vijay Lakshmi, Rumi, Viren, myself, we have been working on this for last 3 months to give finishing touches to this program, and now today it has seen the light of the day. I'm very grateful to them. Well, friends, I am Mr. H.N. Daruwala. I am the host for this program. I am vice chair on the electrical focus, electrical vertical. Welcome to this very important program on EVs. Before I start, a little bit brief on Focus. It's a unique organization which brings all the constituents, all the verticals of the construction industry, the electrical, the HVAC, vertical transportation, firefighting, plumbing, all of them under one umbrella, which goes into building of a built environment. And it's a unique of its kind in the country. And it's headed in India. It's headed by the top class technocrats in the country. And very intelligent knowledge sharing occurs practically every week with important conferences. So this is the brief on Focus, and we are very privileged to host this webinar under your umbrella. So with these few words, I would request a brief introduction of Focus, video tape, video recording on what is Focus about. So over to you.
We are delighted to present to you the Forum of Critical Utility Services, the acronym of which is FOCUS. Much as the acronym suggests, the role of the Forum of Critical Utility Services is to bring in focus all that concerns the construction industry. This is not just for India, but for a coordinated construction industry world over. For those of you who may not be aware, this initiative is to prepare and present a platform where all the verticals of the critical utility services of the construction industry forge into one formidable group that will strive in building unity, aid in diffusing misconceptions, and present itself as a platform for discussions amongst these bodies of professionals. Our efforts begin with drawing the strength from the fields of architecture, electrical, plumbing, HVAC, safety, fire, security, illumination, vertical transportation, IBMS and IT, solid waste management, and last but not the least, facility management. Bring them together and forge them into one strong wheel of change to deliver structures that stand in harmony with Mother Nature on planet Earth. And this, ladies and gentlemen, is our mission. Only when we come together and share our ideas and aspirations will we find the stumbling blocks. It is here then that when we are together and focus towards one goal, we will jointly be able to understand and address our challenges as one formidable force. And this is our vision. Our invitation to you is open. Come and become a part of Focus. It is your contribution and support to Focus that will make a difference to the new India that is being created. Let's join and make this the Bharat that we wear. Shining, prosperous, bright, and a true world leader.
Excellent. Thank you very much, Shilpa. Thank you for sharing the video for Focus. My request to all is it's a very rich organization, rich of knowledge, rich of technology, and request members who are not yet become a member to become members of the Focus and gain absolute information, outstanding information week by week on webinars, seminars, and physical conferences as such. Well, friends, with this, I now come to today's conference. Friends, I consider that we are all very fortunate that we are living in an era which is witnessing the most dramatic revolution in the mode of transportation, which we are accustomed to for last over a century. The first internal combustion engine was invented in 1863 by a Belgian inventor, Eleanor Lenore. Thereafter, after almost 40 years, the first commercial vehicle, the famous Model T, was launched by Mr. Henry Ford in 1908. Since then, for last over 150 years, we are using this almost the same technology which was invented by Mr. Leonore in 1863. Of course, there are many significant changes, inventions, alterations in the engine design has gone through in last 150 years. In the design of the engine, the fuel efficiency, the type of combustion, spark ignition, compression ignition, and many other things have come into existence from time to time, which has made the engine very powerful, very efficient, and very pollutant free. However, the basic funda of burning hydrocarbon in a closed environment to generate energy, which gets converted into motion, remains the same for last 150 years. Now the world has woken up to the green transportation, and that's the need of the hour to save the planet, to bring down the carbon emission and the carbon footprint. So the EVs have come into existence. EVs are entirely different kettle of fish compared to an internal combustion engine. The IC engine has somewhere around 2000 moving parts compared to a EV which has got only 20 moving parts. A dramatic change in our transportation methods. The fueling mechanism changes drastically. The traditional maintenance servicing also goes out of the window. Millions of garages, roadside mechanics who presently service and repair the internal combustion engine and its parts will be no more needed. A new type and a different type of fueling and servicing will come into existence. But the $1,000,000 question is: are the consumers ready to select and use and safe use of an EV? While buying an IC internal combustion engine, one is well equipped with the data like what is the type of car, type of fuel, how many seater, which fuel, what is the efficiency, what mileage. We are all aware of that. However, while buying an EV, what are the knowledge that we should have to buy other than just whether we should buy a sedan or a coupe or an SUV or a hatchback? More than that, do we have any other information? We need to educate the consumer in how to select an EV and what is the best choice for him. This brings us to the most important topic. What are the standards governing the EV? What are the battery types? What are the battery standards? What are the ideal charging methods and how safe we can make an EV? This conference today will throw light on these very important subjects, and we will try to get the best out of the experts panel which we have assembled today. Further to above, what the impact will have EV on built environment. The new buildings coming up will certainly be equipped with EV charging facilities for at least 2 to 3 cars per family and provide safe charging facility. What about existing buildings? Over 70 to 80% of the buildings existing are existing buildings. With avalanche of new EVs coming in existing building, equipped with will the equipment take the load of the existing building? A typical household family will have a total connected load of, let's say, about 15, 20, maybe 25 kilowatt. Now the same will shoot up almost double with about a EV, 1 or 2 EV coming in a family. The building connected load will also shoot up. Will the electrical systems, the transformer capacities, the distribution, etc., will take the load? The worst fear is a new car owner, after getting an EV, will call a roadside mechanic or a wireman to provide an electrical outlet to charge the EV. What safety norms will he follow? What are the protections which he will adhere to? Presently, a very small volume of EVs are existing in the market, and even then, we see a number of incidents reported: fire in charging systems, overcharging, fires in batteries exploding. What disaster is waiting to happen if all of a sudden hundreds of EVs come into existing building? Well, friends, today's conference is going to address some of, if not all of these questions, from the transition of IC engine to EVs as smooth as possible, safe and beneficial to the customers and the environment. I am sure at the end of today's day, we'll all be rich in knowledge of not only the selection of the EV for the family, but also safe usage of the same. Friends, this is just the starting. The electrical vertical of focus is looking at much more subsequent programs coming up, wherein in the coming new programs, we are also going to get EV manufacturers, two-wheelers, three-wheelers, and battery manufacturers in a webinar or a physical conference, as the case may be. With this brief introduction, I would once again like to thank all my members of the electrical vertical who has helped me in last 3 months in shaping out this program. With this brief introduction of today's program, I would like to introduce and thank all the panel members. A special thanks to Mr. Ashok Sethi and Dr. Malur, who has been represented by Ms. Geeta Lakshmi and Ms. Shanti from Tata Consultancy, who have been nominated by them for this program. With great thanks to Madhurima, Dr. Rashi, Mr. Vimal Kumar for participating in this program. We'll have a brief introduction. So over to you, Shilpa. Yeah, Mr. Bhavani Prasad is the Director General Works, an engineering organization of the government. He has got a number of eminent awards, and out of 38 years of service, he has served 5 years in Iraq. Most important achievements: the border flooding light fencing and road along the Indo-Pak and Indo-Bangladesh border, visiting faculties in a number of schools and planning and architectural, introduction of computers for estimation, preparation, account, budget, etc. in CPWD. A very important member, and he is a chairman of the electrical vertical. Next, who will not know Mr. V. Suresh? He is my guru for last so many years, heading as a chairman of the IGBC. He is a civil engineer with experience of 54 years in urban development, infrastructure, real estate. He was CMD of Woodco with all around growth in housing, infrastructure, innovation. A member of the expert group of EIA, Infra Projects of Ministry of Environment and Forest and Climate Change, member of Advisory Council for Rebuilding Kerala, and member of Kerala Government Committee for Housing and Habitat Policy. He is the chairman of IGBC. He has achieved more than 16 awards and recognition, and to cap it with an CIDC Industry Diwan Award of 2011. He is the president and Good Governance Indian Foundation for Good Urban Governance. A very energetic person. He drives everything with ultra modern energies, ultra high energies, and makes everybody run after him. So thank you very much, Mr. Suresh, for presiding on this.
Thank you.
Mr. Vimal Kumar is the chief speaker. Thank you, Mr. Vimal Kumar. You are the chief engineer, CPWD, deals with technical and legal policy guidelines of CPWD and technology applications and specifications. You are also member of Make in India and Green Rating System, Sustainability, Accessible India, New Technology, and New Material for Electrical Working. So you are a member of all that, having nearly 32 years of experience in the field of construction management, maintenance management, project planning, design execution. Was recipient of the Director General Medal for Best Chief Engineer Award for the year 2018-2019. So we welcome Mr. Vimal Kumar. We are indeed very grateful for you to be participating in this program, Mr. Kumar. Next is Dr. Shanti Ma'am. She is the Group Sector Head, Transmission Distribution at Tata Consulting Engineers in distribution in T&D sector for the power distribution utilities. She joined TEC as a training engineer and rising over last so many years and heading the division now with 28 years of experience in design of power plants. Worked in several large coal-based and gas-based power plants, working on power plants including 500 megawatt and 4,000 megawatt, 5 to 800 megawatt ultra mega power plants, and 1,100 combined heat cycle power plants. She has worked on several feasibility studies. She has trained a complete group of engineers under her as a mentor, and brought them into a very powerful team of engineers with experience on OPEX and CPEX on solar PV, concentrated solar power, battery energy source, wind and hybrid. So thank you, ma'am, Shanti ma'am, for joining us as a panelist. Ms. Geeta Lakshmi, she is also from TC discipline heads with electrical head with 21 years of service in electrical systems and engineering in various power plants, industry, building and smart buildings. She is a qualified energy auditor. In current role, she focuses mainly on energy transition projects, which include battery energy storage, microgrid, sustainable development, and electric vehicle charging infrastructure. So we are very lucky to have you, Ms. Geeta Lakshmi. We look forward to your valuable contribution. And finally, of course, we have got Madhuri ma'am, She is from Bureau of Energy and she is a scientist in Bureau of Indian Standards with BITS in Dhanbad. In her 19 years experience, she has worked for around 3 years in the Central Road Research Institute, and prior to joining the BIS, she is CRRI and is involved in research in the field of fiber reinforcement for the concrete with material admixture. Presently, she is working at Scientist D in Civil Engineering Department of BIS, and during our interaction with her, she has brought lots of value addition to this program. So thank you very much. Thank you very much, Madhurima ma'am, for joining this program, and we look forward to your valuable contribution. Last but not the least, Dr. Rashi Gupta, Battery Wali Bhai. I mean, that's a very good name which has been is a pioneer in manufacturing of advanced lithium batteries in India, along with world's smartest lithium battery. She's the founder and managing director of Vision Mechatronics Private Limited, leading in towards the name in the robotics, renewable energy storage. A woman entrepreneur who has been fearless and ferocious in creating a brand for herself and the company. She has done a lot of work in lithium ion, and we look forward to you, ma'am, for your valuable contribution. Thank you very much, Mr. Suresh, for bringing in Dr. Rashi Gupta into this conversation, and we are sure she will add a lot of value. She has been awarded Corporate Guru World Award 2021 for her work in SDG 5 and SDG 7. She is featuring among the top 40 global women leaders in the energy storage since 2022. Thank you, ma'am, for joining us. This is a brief description of all the speakers, and I'm sure today at the end of the day, we will have a lot of wisdom on EVs batteries, and how do we go about safe use of EVs, trying to green the environment as much as possible. With these few words, I will now request Mr. Bhavani Prasad ji, my chairman, to deliver a keynote address. Mr. Prasad, you can take about 5 to 7 minutes in delivering the keynote address, please. Shilpa, Mr. Bhavani Prasad there?
Yeah, Saab is there. Saab is very well there.
Yes, he's there.
Is it okay? Yeah, okay, sir. We can hear him.
Namaskar.
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 Thank you, Mr. Daruwala.
Welcome.
I'll just start with a few words on how this program came up to be taken up. No doubt, electric vehicles have been the rage of the state, have been of interest all through. And I recall one of the star attraction when I was in the school was the Mysore exhibition. You would go for the one important thing was the go-kart bikes or the cars which used to be used. But today we have changed it over from this thing. And going into EVs are of interest from the national level because we will be switching over from the hydrocarbon, petroleum products over to electricity. So our dependency on petroleum would decrease with each change of vesting to. Apart from that, the question is also about the carbon production. The carbon dioxide production from the vehicles which are on the street and which are polluting many of our cities would be shifted. This, of course, is a highly debated or debatable question. We might be doing the same thing as what we did in the case of garbage. The cities came up, the garbage was being thrown outside in an unused area, and the problem has got shifted to this thing. Similarly, our shifting over to electricity would still be producing the carbon dioxide somewhere else apart from the extent to which we are dependent on the renewable energies. These are few of the questions which are, as Mr. Daruwala pointed out, the significant advantages that will be coming up out of electric vehicles would be its components. While an internal combustion engine would have about 28,000 or more parts, and many of them would be having physical friction rubbing and deterioration thereof. The electric vehicle has got about 5,000 to 5,500 parts corresponding to this thing, which would enhance the reliability, dependability, and maintainability. I would like to talk about as to why this program came up. We in our complex have got about parking for about 380 vehicles, and out of that, as of date, there are about 6 people who have got electric vehicles and have switched over and they are existing. And we are experts in Jugaad. Now, the moment the person purchased the vehicle, he wanted an outlet testing, and he called the electrician and he got it done. Now, that is a socket which has been put on the column, which is about 60 meters away from the place where it has been tapped, and is connected and put with a flexible 3-core flexible wire cable, which is. Now that is the situation. Another person has got it done with a PVC conduit. Now, like that, haphazard extensions have taken place for the 6 or 7 units which have already been used. Now, when it is 5 or 6 are this thing, it is still not an uncontrolled situation. As of now, we do not have any clear specifications or directions as to how we should go. As such, we are seriously in need of specifications, guidance, codes of practice necessary for this thing. Our normal practice has been, of course, it's a good method that we bring out the standard on the basis of consensus after taking all parties who are concerned with an item with their due approval. And quite often this leads to a little bit of compromise. So in this case, we thought that we will start with this thing before the problem goes out of hand and let the National Building Code, which is the leading document on this issue of buildings and the infrastructure in buildings first thing. So take care and cover the requirements of the electric vehicles also. The other aspect which comes to my mind is about the charging infrastructure as a whole, not within buildings, but wherever or whoever has put it. The availability of charging infrastructure is closely connected with the size of the battery. And the battery size, the battery contributes about 60% of the cost of the vehicle. And if there are frequent charging facilities, probably the size of the battery would go down and would also reduce the cost, which would help in switching over to electric vehicles at a faster rate. One example is today the Yulu two-wheeler, which is, I don't know whether in which cities it is existing. It's in Bangalore, Ahmedabad, Delhi, etc., wherein it appears to be quite a popular success for the last mile travel, say from the metro station to the house, which may be not too close, but yet not too far off, where you have a problem. Walking is difficult. There is no alternative thing, and you are dependent on it. The second thing is, India has its own modes of dependency on transport. And with us, the auto is one of the, or the three-wheeler is one of the popular modes of this. The development should take place in such a manner that our thing, we should depart maybe from the experience of the European countries, and we should develop our own requirement of systems for further development on the vehicle and its suitability. Well, with that, I would not like to elaborate anything further because we have a galaxy of experts on transmission and distribution, expert on electrical distribution and batteries, and then battery specialist. And then you have also Mr. Vimal Kumar on what the government is thinking and what, and CPWD being one of the organizations which is handling all types of buildings in a very large scale. and is also developing the standards of this. And in addition to that, we have Madhurima, who is looking after the standards and is also bringing in this thing, coordinated effort from different sections of BIS, which is contributing towards the need for standardization. One of the serious problems that we face every day in our houses also is every device, everything that you plug in, some plugs go in properly, some do not. Standardization is a necessity. And as far as this program goes, this I expect to be the first program in the series because we will not be able to cover various aspects. Battery is a very important point, and the improvement on batteries during the last 10 years has been tremendous. And at the same rate, what is to be projected, I leave it to Dr. Rashi Gupta to project and what she expects. Maybe tomorrow we will have the sodium batteries also coming in, and maybe the lithium batteries also would face a similar situation as what we face with the petroleum, OPEC, etc. fallouts, which created a problem because lithium, cobalt, etc. are also from restricted areas of supply, which will affect this. It is also of interest that to what extent India would grow to develop and make in India is an important thing. So there is scope for exchange of views in a number of related issues. And I expect this to be the first program covering the essentials. And we look forward to have further programs. No doubt, this program may not be of interest to all members of this thing. And so the response of about 175 or 200 participation is this thing, but that itself is a very good number as I consider it, though the normal participation in focus programs have been of the order of 500 to 600. I would also like to take this opportunity to mention the contribution of Mr. Rumi, Mr. Virender, Mr. Dominic, and Shilpa for bringing in together and bringing up the organization of this. I hand you over back to Mr. Darwala to proceed with the program.
Thank you very much, Mr. Bhavani Prasad. You indeed hit the nail on the head. Having a webinar or a physical conference on two-wheelers and four-wheelers EV will attract definitely much more footfalls than this particular program. But this program is vitally important from the safety point of view. What are the standards people should understand? We are trying to educate people what they should look for in an EV and the battery charging facilities, and what are the safe way we can handle it in built environment, especially in the existing building, to avoid the disasters as such. So well said. And as you rightly said, this is just the beginning. Subsequent programs will dwell more on EVs, batteries, standards, two-wheelers and four-wheelers, which I'm sure will be more attractive and will attract more footfalls. With this, I now hand over to Mr. V. Suresh. Mr. Suresh, our chief moderator. Sir, you have got a very powerful panel members to tackle with. I'm sure you will bring out the best in them. Your first panel will take about 40 minutes, in which case you will be talking about the standards governing the programs, governing the EVs and the batteries. And the second one, which will be about 30 minutes, which will take care of the built environment and how it is going to affect the existing building and the built environment. So over to you, Mr. Suresh. All the best. I will go mute now.
Thank you very much, Darwala ji, as well as Bhavani Prasad ji, for the wonderful opening remarks. What a great pleasure to welcome our very distinguished panel with Mrs. Shanti, Gita Lakshmi, Madhurima, Rashi Gupta, and Vimal Kumar ji. What an array of distinguished speakers. I'm very fortunate to get them all. And as rightly told by Bhavani Prasad, this is a topic first time being done by Focus, and not many have done the EV component so far in the way in which we are going to go into this area. It's going to be a series of initiatives. The first one which we done on the technology and the application area, but then equally important is the industry, how they are getting prepared. That will come in the next one with the automobile industry of the vehicles getting changed to that particular EV one, what needs to be at that level. That's going to be a much larger issue coming later. We are all in the context of the phenomenal demographic growth going from 100 crores to 140 crores in 20 years time period. 40 crores getting added is not a joke in 2 crores every year. The demand for housing, the demand for development in a large way, and also the energy consumption. And energy component, roughly around 28% goes to the building energy component, but equally important, the mobility component energy that goes over there, it's of the order of roughly around equally 26%. So we are now getting in that particular area where in the context of the climate change agenda, number one, where the whole world, 193 countries are really working on the nature of changes required for that. Our own Prime Minister's commitment that by 2030 Sustainable Development Goal here, we will have at least 50% of all our energy coming through the non-hydrocarbon material, and that will be renewable other energy, and 550 gigawatt of energy is going to come from that, from 125 gigawatt at this particular point. It slightly increased also the last 1 month period there. So we are all working in that particular segment in a large way, and therefore what needs to be done, there are a series of issues. As I said, the technology related issues, one major component there. So our technical session number one that will be coming over there, and we will be discussing of not only the issues related to EVs, the need, the advantages, the grid management issue, as well as the sag and swell in the transmission network, and issues related to the standards governing the EVs. I'm sure Madhurima will open out on the regulatory and policy framework. Equally important, many departments are involved. The Grid Electricity Agency, Central Electricity Authorities are there. The commissions are involved in that. And how do we deal with the electricity at the supply level? More important is at the housing level, in the building level, in the office complex level, the factory level, the mall level, everywhere. What you have in that particular segment is equally important. More important is all that is the energy storage issue that will be all discussed in the technical session one. The 4 speakers are already identified to deal with that. Also, the regulatory policy and advocacy issues also have got to be brought in over there. We have 4 outstanding speakers. Their own presentations are brilliant. I have seen that. At least 3 of them I have seen that. I'm sure the others will be coming. Try to keep it a little taut. Get on to your main thrust area, even if you have slides available earlier, because the time we are just around looking at the watch there, about 11:32 or 11:33 now. So with each one of them taking around 10 to 12 minutes, I said originally 15 minutes you can take, see whether how you can best cover. And the order in which I'm going to invite are going to be the following. And I'm going to invite Mrs. Shanti to come and make the first presentation. And that is going to be the presentation in respect of the impact of electrical vehicles on built environment and standards. I'm sure the presenter is already given details. She has already been introduced over there. She will talk about the futuristic smart grid, vehicle to grid, grid to vehicle, and the issues on sag and swell and all the related harmonics and the related area. Want to close with only one more observation. While we are trying to get in for the EV, you got to know suddenly there will be a thrust coming for the electrical load coming from the grid in a very large way. So therefore, the electrical generation capacity also has got to be increased. Can it come through the normal grid only, or can you do through a renewable is the question number one. I thought we may have to really address how much of solar power for charging also can be brought into the particular area. And the second component is the coordination, linkage or integration with the vehicle manufacturers and the point related to the regulations coming over there. I'm part of the Ministry of Environment Forest, where we have put already condition that 20% of all the vehicle has got to be EV. All vehicles, whether it's going to office or residence, whatever, and charging points have got to be provided in the particular in buildings there. And based on development control rules, I'm sure Madhurima can open out, we have put that even if you put many basement, but the electric charging point should be only in basement number one. Don't put lower, put it all clubbed together. These are details on working nitty-gritties of making it work. Stop at this point of time. And I request straight away Shanti to take over and take the next 12 minutes, Shanti, to make your presentation. I saw your presentation is very good. I'm sure you'll make it snappy and fast. About 20 odd slides can easily be done in 12 minutes. Okay, go ahead.
Thank you, sir. Thank you very much. Thank you, Focus, for first of all, giving me this opportunity to present my slides. I'm just sharing the screen, sir. Give me a minute.
Yes, please do.
Please let me know once my screen is visible.
Yeah, I think it's coming. You started sharing.
Yeah, it has come.
It is visible, a full
Yeah,
screen.
it's already come. It's already come.
Yeah, thank you very much.
Can we put on the full screen so that maybe
It
only
is
you can
already in the
use?
full screen,
So
sir.
it's a full screen,
It's
sir.
a full screen, sir. It's a full screen, sir.
Okay, I'm happy. I was thinking the whole thing, but only her photo. None of us is relevant when she presents. Okay, no problem. Please go ahead.
Is it visible?
Yeah, it's very visible.
Yeah. Thank you very much. Thank you for this opportunity. I am actually very happy to be a part of this discussion today, and I understand this is the first in this series of discussions. So, I'm also very happy to be amidst eminent panelists in this session, and also the chair of this forum, Mr. Darwala, the chief speaker, Mr. Suresh, and also Mr. Bhavani Prasad, and I am also my co-panelist. I'm happy to be a part of this. And as a brief, as we all know that the world is actually embracing change, maybe because of the climate change, as we are all aware. So we are at the threshold or at the cusp of energy transition, which is imminent. And as in fact, I would like to also jocularly say that even my career has also seen a transition. As you would have seen in my introduction, I originally started with the engineering of coal-based and gas-based plants. For the last 5-6 years, I'm very much into renewable. And I have also, of course, we all need to change. That is good for all of us. Just on the lighter side, just so to get a context, I just made strides or something like this. Of course, I will not go into each and every one of them, respecting time. Coming to the, I just wanted to say, as we are all been discussing, and also as the opening remark and the key speaker also, see, as per the World Economic Forum, energy transition is a timely transition, which is actually has to be more inclusive and sustainable. That's a key word. And so that we have, it becomes affordable, and also we have to respect the energy triangle. Basically, it has to be a security for all. It is sustainable, and it has to be growth enabled. And also, first of all, it takes care of the needs of the people. So we all know that we are at this very important, crucial junction where all the countries and corporates are, declaring their climate goals. So it's very, very important that every sector has to actually embrace change in the right direction so that we remain sustainable. So just give you a snapshot as per the recent estimate of this World Economic Forum, basically that fostering effective energy transition, we see that the different sectors which contribute towards the emissions, we can see that, of course, the 5 heavy industries present 80% of the industrial emissions. But we should not also miss out the transportation sector, as was just told by our earlier speaker also, contributes quite a bit. It contributes about 16% of the energy of the CO2 emissions. So it is a section, it's a sector which needs close attention. Just to carry on with the same aspects, in fact, we all know that there are forums, like there are international bodies like the IRENA or the EA, who are doing a lot of research and studies, in this domain to find out what will be the situation scenario, how going forward, how we can contain, what actions we can take today so that we limit our the temperature rise to less than 1 degree, desirably 1.5 or 2 degrees, less than that, so that they have a closer look. And in fact, every sector is being analyzed in a very close manner to see that where all we can bring change. Normally, there are sectors like, iron and steel, cement, chemicals, and petrochemicals and aluminum, where actually they are all called as hard to abate sectors, where a lot of changes are required to bring about the reduction in CO2. It's not so easy. Whereas there are some sectors which are easy to electrify. For example, this transportation is one sector which is probably considered a little easier, where electrification is possible. So coming to transportation as such, totally, as I just mentioned, of the 16% emissions, there are three major components: the road, freight, aviation, and shipping. So if you say road freight, it contributes about 27% of the carbon dioxide emissions. And in fact, there has been studies to say that what are the ways we can reduce that, in the sense everything cannot be electrified, as we are all aware. So there are different components. For example, we can reduce, first of all, the demand and improve the energy efficiency of the systems which are already in place. Or we can, of course, use direct use of clean electricity, and we can use renewable heat and biomass, and use of synthetic fuels and feedstocks. For example, even in the combustion engines and others which require fossil fuels, probably we can shift it to cleaner fuels like synthetic fuels. And you may be aware that many industries, be it iron and steel or cement or petrochemicals, they
For the
are
next
all
slide.
working a lot of issues. They're taking a lot of initiatives to move to synthetic and biofuels and blending to start with, and probably replacement in the the near future. So considering the transportation sector, what are the options for reaching the net zero, the so-called net zero, is basically the first option obviously would be to go for battery electric vehicles. And we all know that all vehicles, of course, cannot be directly electrified because of various reasons. The capacity, we know that the large vehicles or the heavy density vehicles or the bigger vehicles, where probably fuel cell is another good option. And of course, blending, I talked to you on the fuel blending, is on the biofuels. So these are some of the ways. There are a lot of research, and they have decided that probably these three could be a good solution to take us to net zero.
Shantiji, you have to go a little more faster. You're still on slide 1. You got 20 more to go. And only 6 more minutes to go. So you
Sure,
can make it faster. On the first slide, you took 10 minutes. Thank you. Go ahead.
Sure. Thank you for prompting me, sir.
Yeah.
So coming to the EV initiative, we are all aware that the EV 30 at 30, by 2030, they want to actually have 30% of vehicles on the road to be EV. We know that many countries are signatory to that. And in fact, India is on a signatory, as we all know. So basically, as we all know, that the electrification of transport not only helps, of course, it helps embracing direct electricity and reducing pollution. It also helps us in reducing oil imports, and also will be contributing to climate change. So it's an estimate says that about by 2030, 4% of the total electricity demand would be required for EV. And of course, we'll be reducing a lot of so many barrels of per day of the oil. Of course, there are a lot of statistics. Of course, I'm not going to get into these details, but as we can see that there's a tremendous improvement in the, the embracing EV in the last few years. And in fact, we saw just a tripling in just last 3 years. And as I also see that the population is increased even on the heavy density vehicles like the buses and the trucks, which is a very good sign and towards EV promotion. As of course, we can see that along with that, we also ought to see that the stock and sales have increased, and there are different scenarios which is being worked out by the International Energy Agency. And there are different scenarios which say that how these can be, gradually taking into a net zero scenario in by 2050. That is ultimate aim. So when we come to the challenges in embracing EV, when we say so much about EV, then why don't we adopt it, right away? Of course, it's easier said than done. We can see that there are many challenges in EV. As any new technology, there comes a challenge, right? So of course, purchasing price, charging time. There's an important thing because it's not just like refueling your diesel or petrol at the fueling station. It takes some time. And of course, we should have the right infrastructure available. For example, somebody would want a charging station like as many as the number of petrol pump or outlet today. So these are some of the challenges. And also, as we have just mentioned earlier, there are some risks, and will remain also some threats and risks which we have to be carefully evaluated and taken care in the manufacturing of this vehicle as well as the charging station design. So I'm sure many other panelists would be covering those aspects of standardization and how we can make it safe. So of course, charging, if we say that, we know that there are many types of chargers. I'm not going to get into details of this. Basically, as we all know, it's basically a motor controller and battery charger. Is going basically the electrical systems are going to be in the vehicle, which is going to do the charging. Of course, there are different types of chargers, whether it is the home or office, what kind of charging can be done, and different levels of charging is available. So maybe we will be sharing our slides, and probably somebody who's interested in the details can go through that. And of course, we are moving towards fast charging, where earlier charging time used to be hours. Now probably we can talk about minutes. And also there is a continuous evolution or development in this area, which is going to help us embrace EV faster. So coming to the main grid impact, as we all know that as we are expecting a higher consumption of electricity because of EV, we also need to be aware about how our electrical systems are designed, basically the transmission and distribution systems. So basically, first of all, we need to have enough sources to power them, and also enough the lines and transformers basically in the transmission and the distribution sector have to be enabled and also to nature. The one is the quantum of power, other is the nature of power, because basically we are all aware that the battery and charger, of course, it is not a perfect sinusoidal wave, it is going to take the power. So basically, nature of the power, how it is drawing, it also varies. So we have to be really careful in assessing what impact it is going to. A lot of studies are going on, again, as I said, in both the developed countries and the developing countries, to see how the grids are enabled, or how they are, today available to cater to these requirements, and how we can modify, to take care of the future requirements, which is imminent. Actually, we have to take care of that. So generally what is the study says that up to about 2030, the general feedback is that more or less the grids are stable enough, and their capacity is available to take care of these requirements, especially in developed countries. But of course, in developing countries, there are some additional upgradations to be done in the distribution side, because first of all, we always have a shortage of, or shortfall, in the systems to take care of the, as it is, present loads. So definitely EV is going to add more stress on the distribution system. So we have to also manage the demand response. It's not that, we will uncontrolled charging, as somebody was telling in the previous discussion, that if it is rampant, then it's going to be, the grid is going to be haywire. So we have to go for controlled charging and smart charging, and have a regulated demand response, which will really help us in balancing the requirements and the availability, so that we also will not spend disproportionate amounts on the investments on the grid enhancement. So these have to be carefully evaluated, and I'm sure that we are all working towards that. The industry, the academia, and other forums are definitely working towards this. As I just mentioned, like, of course, harmonics, because of the nature of the loads, flicker, these are all very common because of the type of load which is being drawn. Of course, we have to overcome this. We are at actually the tip of the iceberg, I would say, in terms of this. And as India is taking baby steps towards this, there are some learnings which can be best practices, which can be embraced from the developed world. And definitely, I think we are poised in we are in a very good position where we will be able to take on this. And of course, I cannot neglect the impact of RE integration into the grid. Of course, RE has its own challenges in terms of variability and the informed nature of power. But of course, they can be a good combination, I would say. The RE and the EV can be a good combination, provided we make use of the smart charging and, control charging, to see that, EVs are charged when the renewable sources are available. And also, this also helps us to decongest the distribution network, and which, by having distributed generation, it really helps us to, take on in a better way our country. And also, as we all know, that India, it will definitely help India in being self-sufficient and, reduce the dependency on oil and imports, which will really help us also, considering the ambitious renewable energy target we have. Definitely, it can be a win-win situation for all of us. Thank you very much.
Yeah, it's where you kept it. I kept till 11:50, and you're on dot. Just finished on exactly on dot. Thank you so much. It's for others to now follow the pretty, and fantastic. 4% of the total energy is what's going to come by EV. I was having a projection. I don't know from where I got that. I had a figure of 6.5. I don't know. It's okay. It's good. But if the number of vehicles are going to become more than the projection, possibly that loaded. But I'm happy last slide brought in the RE component, because not put all the eggs in the grid baskets only. To use that also is equally important. Thank you so much. With that outstanding start given, let me invite.
Thank you, sir.
Geeta Lakshmi she's going to talk in terms of the impact and mitigation plans. Come, I think Geeta, you can take it over.
Yeah, sir. Thank you, sir.
I also saw your presentation. Okay.
Please allow me a minute to share my screen.
Sure. Please do that. And for those who already done the presentation, keep the chat box is very, very active, and it's coming every minute. Some questions are coming on what all areas they should work on, etc. So I'm sure I'll ask them questions.
Is my screen visible?
Very, very visible, Geeta. Go ahead. You are the head of
A very good morning to everyone. So myself, Geeta Lakshmi, is discipline head electrical, and mainly involved in technological projects like battery energy storage, microgrid design, and the EV infrastructure design. So I'm very happy to be a part of panelist in this esteemed forum, and I thank for giving this opportunity. So in the interest of this time, let me start my presentation. So maybe in the next 12 to 15 minutes, I'll be covering on the EV grid interface mitigation
Not
plan.
15, not 15, make it 12. That's it.
Okay.
12, you should finish off. I'll give a signal 2 minutes earlier. Okay.
Smart charging.
Please go ahead. Please go ahead.
Yeah,
Please go ahead.
smart charge, and we will see the smart charging techniques and
Speed.
also on the smart charging services to the grid.
Yeah.
So coming on to the mitigation measures, we have seen in the previous session the various impacts of the EV interface on the grid. In a nutshell, the core reason for most of the impact is uncontrolled charging. It is evident that uncontrolled charging increases the peak demand on the grid to a new level as EV peak demand coincides with the normal peak generally. So this will eventually result in grid disturbances as discussed earlier, such as equipment overloading, network overloading, congestion, sag and swell, and power quality issues and so on. So these impacts are cascaded at every part of the system, that is at the generating station, transmission, distribution, and at the consumer level. Before entering into the mitigation measures, I would like to present a case study carried out by IIT for various Indian states, which substantiates the statement that EV peak coincides with the conventional load peak. This is mainly due to the reason that 80% of the charging takes place at home, which will be at the evening and the morning hours. So now let's look into the mitigation measures. The two main mitigation measures seen are the passive management of the load, which is TOE, that is the time of use and the time of day tariff, and the real-time pricing and the smart charging. So when you say passive management, it is actually basically to influence the charging behavior of the users with discounted tariff during the off-peak hours. So this has been so there will be a low tariff during the off-peak hours. You can see on the right-hand side the variable tariff. And this has been well received in many countries such as US, UK, Japan, China, Europe, etc. And as well as in India, the states like Delhi, Maharashtra, UP and Telangana has announced this TOU tariff. And also the real-time pricing. So what this TOU tariff does? So it helps to change the behavior of the charging. That is, during the low peak hours, the charging happens, and during so that you can avoid the peak load of the EV. Similarly, real-time tariff is actually, it is a dynamic pricing model which depends on the real-time cost of the energy. And one more key important point in this is this real-time pricing should be closely connected to the wholesale market. So it requires enabling technologies such as smart meters, two-way communication. Though some of the utilities like Illinois, Nova Scotia Power, Canada offers the real-time pricing model, this is still in the incipient stage, and the implementation is limited in the real-time pricing. So now let's move on to the smart charging. Fine. Smart charging. So what is a smart charging? There are various definitions and explanations moving around in the web for smart charging. So we may discuss few of them here. In simple, smart charging means adapting the charging cycle of EVs to both the conditions of the power system and the need of the vehicle users. And the key requirement in this is it is imperative to establish a data connection between the charging device and the electric vehicle to make the optimal use of the energy. Next, to answer the question, how charging is done using a smart charger. Smart charging is done either by customers responding to the price signals or the EV equipment automated response to the control signals that react to the grid and the market situation, or the combination of the two. And we can see here there are various forms of smart charging like V1G, which is nothing but grid to vehicle. It's a unidirectional control charging. And next is the V2G, which is a vehicle to grid, and vehicle to home, vehicle to building, vehicle to vehicle, and many other technologies as well. So each type has its own flexibility. Each provides a flexibility to the power systems. Now let's have a quick dive into the V1G and V2G technology, its comparison, use case, and the benefits. V1G, it is a unidirectional control charging. That is, vehicle is charged from the grid, which is a conventional, what we have now. That is, the power flow is unidirection from the grid to the vehicle. Through data connection, this allows EV to modify dynamically the charging time based on the pricing model. So depending upon the pricing model, the charging time and the rate can be modified by the EV users. So let us see a use case. A vehicle comes to the depot at 6 p.m. in the night and has to depart at 7 a.m. in the morning. So instead of immediately charging at 6 p.m. in the night, at the evening when the prices are prices are high and the peak demand, it waits and the vehicle gets charged at 12 a.m. and it gets completed before the departing time, that is 7 a.m. So we can see here the advantage what we are getting is the peak demand is reduced, and as well as the cost saving also is done. And it is encouraging to know that in Netherlands, most of the charging stations are already having V1G capability. Moving on to the V2G. V2G is a bidirectional control charging. That is, conventionally, a vehicle gets charged from the grid. But in addition, in this, the technology allows the EV to feed power into the grid. That is, the EV battery can discharge power into the grid. So with this V2G, the EV battery becomes an extension of the electrical grid. It can store energy, that is the charging during low peak hours with less cost, and feed back the energy into the grid with during the high demand based on the signal received. So V2G offers various benefits to the power system, which will be dealt in the subsequent slides. But to make a point, by and large, it helps to optimize the grid, and also it generates additional revenue to the EV owners. Moving on to V2H and V2B. V2H, that is vehicle to home and vehicle to building, is similar to V2G, with the difference that V2H and V2B is a connection to home and the building instead of the grid. So similar to V2G and V2H, EV can be charged during off-peak hours using the green energy, that is a renewable energy, and then it can use the energy to power the house or a building loads such as lighting, heating, and other equipment as well. So what this offers, it allows the consumer to create their own sustainable energy ecosystem. And notable benefits in this are it reduces the electricity consumption, thereby stabilize the demand on the grid, and significant cost saving, and most importantly, effective utilization of the renewable energy during the renewable production time, and thereby it supports on the carbon emission reduction. Now let's look into another most interesting technology, which is VPP, that is virtual power plant. This is a cloud-based virtual system that aggregates various distributed energy sources. We have seen in the previous session about the distributed energy sources. So this combines the various distributed energy sources such as solar power, batteries, electric vehicles, wind turbines, and so on. So in this, power utilities, renewable energy operators, energy producers, retailers, VPP aggregators or the operators, and the building managers are the key stakeholders. In VPP, EV also plays a key role as one of the distributed energy source, and this provides an efficient way of grid balancing or the energy trade. However, the requirement is that at least 1 or 2 megawatt capacity would be ideal to trade off and make the power viable at the wholesale market. And also this requires at least a 500 vehicle to be aggregated. And VPP, you can see it benefits both the EV aggregators as well as the VPP stakeholders. And,
Geeta, 2 minutes more.
Yes, sir. And so moving on to the V2X. V2X is a wireless technology aimed at enabling data exchange between a vehicle and its surroundings. That is V2P, vehicle to pedestrian, vehicle to vehicle, vehicle to infrastructure, and vehicle to network. So by sharing data such as position, speed, surrounding vehicles, and infrastructure, V2X improves the driver awareness of the upcoming dangers and dramatically improves collision avoidance, resulting in reducing fatalities and injury severity. In addition, V2X will enhance traffic efficiency, providing warning for upcoming traffic congestion, proposing alternative routes, and ensuring eco-friendly driving and reducing the carbon emissions. In most countries, government consider V2X as a critical factor in reducing the road fatalities. As a result, they are pushing the industry to shorten the deployment schedule of the V2X technology. Now, moving on to the smart charging services to the grid. So you might have seen in the earlier discussion the importance of the EV with VRE integration. So the current slide visibly shows the comparison between the conventional charging and the smart charging impact. Generally, uncontrolled charging will not match with the solar generation profile, except for office charging and the partial public charging during the day. Thus, effective utilization of the renewable power is not felt. But by shifting the charging to coincide with the solar generation and by implementation of the V2G, the incremental benefit of the smart charging is seen to be significant in solar-based systems. This necessitates the charging stations to be located at workplaces and other commercial premises where EV owners can park the vehicles during the daytime and charge. For the wind, the scenario is different. There already might be a high match between the wind power production and the EV charging profile. Even with the uncontrolled EV charging, as wind generation may occur at night, that it is coinciding with the EV charging. Thus, with EV smart charging and with VRE integration, the benefits are it reduces the VRE curtailment, and sometimes it can even reduces to zero. Helps in maximizing the VRE renewable consumption and reducing the carbon emission. And most importantly, power system flexibility and resiliency is improved. So, we have deliberated various technologies and the benefits. Now, let me summarize the services which smart charging can offer to the power system. Smart charging provides flexibility to both the system and at the local levels. At the system level, smart charging could facilitate balancing in the wholesale market. So, with the controlled V1G EV charging, the charging patterns could be controlled to flatten the peak demand and support on the real-time balancing of the grid by adjusting the charging levels. And with V2G, by injecting electricity back into the grid, EV also provides ancillary services to transmission system operators such as frequency control and voltage management. No wonder V2G VPP can even cater to emergency backup and as a primary and secondary reserves. It is worth not to mention here that the grid integration specialists such as Enel, Nuvve, and Inserva and as well as the car manufacturers like Nissan, Mitsubishi, and PSA groups have demonstrated the state-of-art technology and the vehicle to support the electricity grid, providing services like frequency and voltage control via V2G technology.
Geeta, I should wind up.
Yes, sir. Another 1 or 2 minutes, and we can see that many studies have been conducted, including IRENA, which says that with uncontrolled charging, you can see 9% of the peak load demand is estimated to be happening with a 0.5% of solar curtailment, whereas with smart charging, only 5% increase in peak demand would happen. Similarly, the other studies also says that the peak demand considerably reduces. And these are some of the snapshot of the smart charging technology piloting, and many car manufacturers are already in the move. So finally, I've come to the last slide. So before concluding this part of the session, let us look into the challenges for the smart chargers. First, the charging infrastructure. Leave apart the conventional charging, leave apart the smart charging infrastructure. Even the conventional charging infrastructure itself is lagging. And when you consider the smart charging infrastructure, like communication network, smart meters, and the control system, all needs to be evaluated and to be prioritized. And on the policies and the regulations, they need a push, and standardization needs to be done to have an interoperability between the EV and the EVSC. And finally, but not the least, battery capability is very important challenge. The life of the battery is based on the charge and the discharge cycles. In the case of a V2G, if you see, battery is discharged the electricity to the grid. So what happens? The life of the battery gets life of the battery gets declined. So this has to be addressed by the battery manufacturers. So
thank you, Geeta. I felt so bad interrupting you, but the fantastic presentation, so many good points. I'm sure in the Q&A, all of you will come back in a big way. Darwalaji, you want to say something immediately? I found you raised.
I want to thank Geeta Lakshmi. Excellent presentation. Thank you.
Okay. Yeah, I found you raised your hand. Let's go through all the wonderful ladies and the presentation there. That brings us to the third presentation going to come from Dr. Rashi Gupta, Battery Wali power person in the country, and Rashi would make all the issue on the storage in a big way, whether going from lead acid to the lithium to sodium or hydrogen. I don't know where all she's going to take us now, and what are the problems, what are the difficult. Some of the people already raised take power of batteries, disposal of the batteries, so many things they raised already on the Q box. I kept on watching. I'm sure. Without taking any further time, Rashi, take your next 12 minutes. Please go ahead. I know you wanted 20 minutes, but I know you're quite capable of
it's okay. I can finish in 10-15 minutes. I can finish in 10 minutes, 10 to 12 minutes I can finish. I need to share my screen. So
take your time. Take your time. I know you will make us very engaging. Please go ahead.
Geeta, can you just unscreen your share, this one sharing?
Any problem in the sharing now?
In the meanwhile, till we do not waste any time, till they are doing the share and unshare of the screen. I see a question here: electrical future rate increasing upcoming day. Means every day the electricity charges are increasing. Is it possible to have a solar bike charge or a car infrastructure? Yes, of course, definitely it is possible. And what I would suggest is that each one of us in our own houses can have a small microgrid, mini grid kind of a thing, which we can use to charge these electric vehicles, as well as how V2G was shown. And at spare time, when the vehicle is not being used, we can use that power again to recharge our houses during the power cut and during even the regular grid times.
Yeah.
So that would help. Now, I would just quickly start with my presentation.
Yes,
and
yes,
that is where
please.
you can see my screen.
Yeah,
Okay,
wonderful.
so I will be talking about what are the EVs types and what is the importance of battery management system, why fires have happened, and what are the ways that we need to be aware on how we can improve the situation of the EVs from the consumer's perspective. So there we go. So there are four types primarily here. One is first is the PHEV, that is the plug-in type of hybrid. Then there is an HEV, which is a hybrid electric vehicle. Then there is a BEV, which is a standard battery electric vehicle, which is the one which is the most in focus right now. And then there is FCEVs, which is the clean fuel cell vehicles. Okay, these are the four broad classifications that are available. Now, what happens in the hybrid electric vehicles, which is the HEVs, which combines the IC engines and as well as the batteries. Now, what happens in this? The primary role of the batteries is to reduce your petrol and diesel consumption. That is your fuel consumption, and that is how your efficiency of the vehicle improves, and you get a better range. Now, there are few players already, Maruti Suzuki, Tata, Kia, they're mild hybrid they're offering, and HEVs are examples you can see is Maruti Suzuki, Ciaz, Grand Vitara, all of these. Honda, in fact, the Honda City new eHEV is actually a very good example of this. Now, plug-in hybrids. So, plug-in hybrids are having both electrical motor and IC engine both in them. And the major difference between HEV and PHEV is that users of the PHEV can charge their batteries at home or even at the EV charging station. Now, the driving range is only on the electric power would be, is very high as compared to HEV, because you have the fuel also coming into picture. Now, there are few HEVs that you can have, PHEVs that you can have is like Toyota Prius, and also the Volvo XC90 and the BMW 7 Series, they are available in India. Now we come to the most focused, that is the battery electric vehicles. Now, in battery electric vehicles, what happens is they're actually a pure EV thing, wherein, you just have pure EV. I'm not mentioning the brand here. I'm just saying that they're actually just the EVs in picture, where only the batteries are having and the electric motors are there, which take the car or the vehicle forward. Now, they're a good option in terms of greening the future, because they replace the fossil fuel consumption. I know there was a question in the chat box which said that, how can you classify them as green when, you're charging them from the source, which is not so green. Agreed, sir, whoever has posted that question. Now, the point is we are all making a lot of efforts to green the grid as well. Lot of efforts are going on renewable energies in every form, reducing the transmission losses, distribution losses, energy storage being added on every aspect is changing the way grid is. You cannot expect an overnight greening of the grid. It is not possible. We have to give it some time. We have just woken up from our deep sleep when the climate is crying and there's a climate emergency. So we have woken up and we are trying to do our best in the shortest possible time that is available. Now, what happens is when you have a complete battery electric vehicle, the efficiency of the vehicle is very high and you have a very reduced pollution. The current electric vehicles that are available in India are Hyundai Kona, Tata Nexon, MG ZSEV, Tigor, Kia EV6, Audi e-tron. All of them are battery electric vehicles. Then there comes the fuel cell, the ones on the hydrogen, which is the most talked tech today. Is about the hydrogen, whether we are talking about the fuel cell vehicles. Well, they are equipped with regenerative braking as well, and they capture a lot of kinetic energy normally, which is lost during the braking, and store it into the battery. When you talk of a fuel cell vehicle, a small segment of battery is there in the fuel cell vehicle as well. Typically, a 300 to 400 miles on a tank of a hydrogen refill and 3 to 5 minutes. Now, this is similar to your petrol tank refilling. There was also one of the questions which I'm taking again is that how can you have really fast charging of the vehicles where we just have an experience same as refueling of the petrol or the diesel vehicles? Well, we need to understand that you're trying to compare an apple with a banana. They're two different techs. And when two different techs are there will be slight differences. Yes, you can charge your battery faster. 15 minutes, 10 minutes charging is available, but you have to understand what is the price you're going to pay for that. Now, price does not always mean the money. It also means the reduced capacity of the battery, the reduced capacity of the vehicle. What is exactly the price you're going to pay for a fast charging? That is also needs to be understood and evaluated whether you really need it or not. Now, sorry about that, types of two electric vehicles that we have, two-wheelers, which is the most popular thing right now. And the India's EV energy transition is fueled and contributed majorly by the electric two-wheelers. Now, there are two types of them. One is the low-speed two-wheeler and one is a high-speed two-wheeler. So low speed would have typically 25 to 45, and actually low speed 25 is the one which does not require an RTO registration. Anything above 25 kilometers per hour would require an RTO registration. Now, the riders, as I said, do not require a public road registration and less than 300 watts motor, but here you have high-speed vehicles. Now, what has happened is, and you can recharge, generally they have a battery capacity of around 3.5 kilowatt hours, which can charge to 15%, 50% within 18-20 minutes. Now, most of this is just a range anxiety that we have. And with that, I mean is that you really do not have a challenge with the range that you're having. You can actually, in your day-to-day travel, once in a while, when you have to travel long distances using these electric vehicles, there is a charging infrastructure available, and you can pre-plan that on the route that you're going very strategically, including checking out which charging stations are functional, which are non-functional. Google has that. There are many other apps which are available and can give you this information live. That really helps you to plan your route very well. Now, when you talk of lithium batteries, now lithium batteries are the most in thing right now at this point of time, and they are likely to be into the segment for at least another 10 years. But at the same time, there'll be more new technologies which will come in, like sodium ion is there, vanadium redox is there, flow batteries are there. Everything will have its market share. The leader will be decided by the cost value analysis or the price value analysis, which will come into picture. But electric vehicle applications typically are even in consumer good electronics, telecommunications, energy storage system, electric vehicles. Now, most of you here are aware what are energy storage and electric vehicles, so I'll not get into that. Now, the major burning issue that every one of us is facing now is we had a lot of fires. 8 to 9 people have lost their lives. Yesterday, there was a major fire where 300 two-wheelers were caught fire, and one old lady lost her life in that. Yesterday's news, that is. So what is happening? Why does all of this happen? This happens because of primarily 4-5 reasons. These are the main reasons, but there could be many other contributing factors as well. Now, the first is the thermal runaway, a short circuit, BMS malfunction, high temperature, low quality cells, or the charging issue. Charging issues has been extensively taken up by my previous two speakers with the impacts that it can have. Now, what is happening is India is importing various cells from various countries, and most importantly, our neighbors. Given the geopolitical situation, India has also launched the PLI scheme for the advanced battery cells, where we are talking of manufacturing of these cells in India by 2025-26. And we are looking at 60% indigenization by 2030 in these cases. And it is very important that we understand that is one aspect in terms of quality. But if you have low quality cells, or if your BMS has not functioned, BMS is the brain of the battery. Just like the cells are the heart of the battery, BMS is the brain of the battery. And it is very crucial that your BMS functions properly. It takes the right decisions at the right time to avert any such kind of a fire incident or any kind of a breakdown of the vehicle due to a battery. Now, thermal runaway. What is a? I'll just first give you what is a BMS. I have certain things to show you here also. Like, see, this is how. Okay, it is not coming on the screen. Wait, can you still see it? No, I'm sorry. I mean, with the virtual background, it is not coming. But a BMS is something that looks like in the photograph here. A battery management system is basically power electronics or electronics, which really helps you, intelligent electronics, which helps you to understand when the battery needs to work, when the battery needs to stop in the layman's language. It is supposed to prevent all the mishaps that can happen into the battery. Now let's come to the functions of the battery management system. The first and the foremost is the battery protection. Prima facie, making it safe. And that is what even Daruwalaji said in his opening remarks, that how can we make it safer? We can make it safer when we have a very good battery management system. Now, the battery management system has to do a cell level monitoring. It may not have IoT capabilities. If it has, fantastic. It could have preventive and predictive monitoring. It may not have it. And active and passive balancing. These are two types of balancing of the cells that are required into the battery management system. State of health, state of charge. These are certain things that it's supposed to do. Now, when you talk of safety parameters, what are the functions? First is the overcurrent, overcharging, discharging, thermal protection, short circuit protections, loose connections. Any of this that is happening, the BMS is supposed to immediately report that, okay, there is some problem, something is not functioning the way it should, immediately cut off. 90% of the fires that have happened did not have these reporting mechanism, did not have any communication, did not have anything where because of which there could have been any report generated that, okay, this was the fault into the battery. Now, IoT capability is something that we really need. We're talking of everything being smart. So why not the batteries being smart? If the batteries are smart, you can do a remote monitoring at any given point of time over the internet and see what is the SOH, what is the state of health, state of charge, what are the temperatures, what are the cycles of the battery remaining from anywhere across the globe. You could have a data acquisition of this entire thing and do a 365 days analysis on what is happening into your battery pack, which cell is weak, which is bad, which is seasoned, what do you have to do next. Then you could even update, the software updates are possible over the air updates are possible. You can control at any given point of time what is happening into your battery pack, thereby controlling your EV and the entire dynamics of the EV. Now,
2 minutes more. Rashi, 2 minutes.
Yeah, enough for me. Preventive and predictive monitoring are very, very crucial. Real-time data monitoring, early diagnosis of the potential failures, remaining use of life. Because see, what happens is when you're talking of EV, one of them also mentioned that it will become redundant. So parts will become, batteries will be seasoned very soon. So when batteries are seasoned soon, no, don't worry. You can identify them if you have preventive predictive monitoring. You can get alerts of unusual behavior. You can have a feedback control. Now, when your seasoned cells are coming out, what you could do is you could reuse and recycle them. Two things can be done. First is reusing them into the second life applications, which are non-critical. And then you could recycle the entire thing. There is a lot of recycling efforts going on into the country right now, because of which you can actually extract 95% of the material of the batteries, recycle them for new use, which will also help you in critical mineral shortage, which is expected because of the large use of lithium-ion batteries. See, this is how a cell level monitoring is done. Each and every cell of the battery pack can be monitored for voltages, temperatures, currents, what is happening inside the battery pack. If you have all of this, you know what can go wrong. You have complete control over the situation. Now, I wanted to quickly show one video on what is active balancing and what is passive balancing before I say thank you and over and out. So this is the video I wanted.
Okay.
Now, this is inside a battery pack where multiple cells are there. Now, these are two different, same two cells, but of different, not capacities, but different strengths rather. Now, see what happens. Now, when the charger is charging, one fellow has become full, the other fellow is half empty. Unused capacity. Now, the same thing would happen in discharging also. Now, this guy who is a weak cell will become empty. The strong cell is still having a lot of unused capacity.
Winding up.
Now, in active balancing, there is an internal charge transfer that happens, which helps a lot into the charging and discharging process.
Oh, that's interesting.
Fantastic. Fantastic.
Fantastic.
So now the entire capacity is completely used during charging. Nobody remains half empty. Now, same thing happens during discharging also, you can have a look. Now, from the stronger cell, it will go to the weaker cell. When the charging, it comes from the weaker cell to the stronger cell. So like this, you actually get the full capacity out of the battery, which is the most crucial thing, because what happens is when your EVs are functional at that point of time. Oh, sorry. So with this, I'm ending my presentation, but I'd like to just say a few things here. What happens is,
I'm in session.
yeah, here, stop. So what happens is when you get the maximum out of your battery, your range is not compromised, the efficiency is not compromised, and you get the best out of the electric vehicles.
Good.
And that is when you will be having a complete greener technology to come. And now one thing about the consumer awareness, just one sentence about the consumer awareness.
Yeah, sure.
So yeah, please understand what, like Daruwalaji said, I was very happy listening to him, because this was exactly what I said in my yesterday's presentation, that for the ICE vehicles, we know what are we going to buy, what are the safety features, how many airbags is there, what is the fuel efficiency, what is the range, kitna deti hai, kitna chalti hai. So all of that we are aware. But do we ask these questions to when you are going to buy an EV? But at that time, as a consumer, what do? Are price kitna hai? How much am I going to pay in the capital? Kitne ka check padna hai? This is what is the question everybody asks.
Good, Rashi, that will take in the Q&A session. Okay. Thank you very much for the fantastic presentation. So beautiful it was. But most important is the issue that we got to know the cost value and price value and each of the things in terms of the longevity, life of each of them, how it works. The cost has to be linked with that particular thing. And I liked it, not apple to carrot, but apple to banana. You put fruit for comparison and not a vegetable with the fruit. So I'm happy you did that. So many interesting points, especially the fire accidents and what needs to be done, beautifully analyzed on that. And what's important is between the active and passive, you're fine leaving both sides happier towards the end of it. That's what the closing point is. Thank you so much. Now we'll get on to out of three fantastic presentations from Shanti, Geeta, and Rashi. I'm going to get on to my colleague in BIS, Madhurima. Madhurima ji, aaiye. Madhav ji, we'll talk on regulatory policy, advocacy, standards, national, international, capacities, operating regulation. Let's hear from what she has done so far, or what is under plan. Even if something is not done, what are things on the annual? Madhurima, please go ahead.
Yes, sir. Thank you very much, sir. Good afternoon, everyone. At the outset, I thank Forum of Critical Utility Services, the esteemed moderator V. Suresh sir and Bhavani Prasad sir, the keynote speaker, Daruwalaji and Mr. Rumi, for providing me this opportunity to showcase in front of you the various standards we have formulated in the field of EV charging infrastructure. Apart from that, I would also be covering regarding the various regulations, policies which are already in place. So let me first kindly allow me, sir, to share my presentation.
Sure, please. A lot of questions and chat box coming. Very interesting points. I'm keeping note of all that. I'm sure it'll be opening out. Each one of you.
My presentation is visible to all of you.
Yes, I think you're slowly opening now. I'm sure it'll be coming. Madhurima started screen sharing, but it's not come.
Is it now there, sir?
No. अब ओपन करिए आ जाएगा
नहीं, it's already there, sir.
शेयर कर रहा हूं शेयर
Sir, I have already shared. It is not visible.
I know it's not on my screen. What about other screen? Is it coming? Darwalaji?
No, it's not there.
Not there. So is a consensus view, not there.
Not on
there.
my screen also.
Just a second.
Any technical glitch there?
Maybe,
Madhurima?
sir. So I will just check.
Toggle F7 again.
Somebody is giving you guidance.
No, sir, I have already shared. I don't know what is the problem. It is maybe it is not getting.
Can you help Shilpa? Your technology person, can you help?
Toggle
Madhurima?
F7 again.
Yes, sir, 1 second. I think so. I've got her PPT. Let me only do that.
We lose time. One minute on this.
Oh, sir. So what I will do, I will start speaking about it.
Yeah, and put somebody on the. You got one of your colleagues next to you sitting. Ask them to help you. That.
No, sir. Actually, I have already shared. I don't need the help of my colleague in sharing
Yeah.
the presentation.
I don't find
think
it
there is
there.
some
But have you
problem.
shared it with Shilpa?
I have shared my presentation with you also, sir.
So Shilpa, can you put it on if you have it? If she has shared it with you, can you put it on?
Yes, sir. Just a second, sir.
Please help her. Please help Madhurima. Thank you, Shilpa. Yeah, you start your presentation. Talk about it. Don't lose time. Silence is not good. Continue talking.
Yeah, so basically, we all know that tackling climate change is a global issue, and there are various authorities who are already in India trying to tackle this through the various policies, regulations, and standards. So coming to BIS, which is the national standards body of the country, here in BIS, we have 3 technical committees. One in our electrotechnical department, which is ETD 51, which has formulated various standards on e-vehicle battery infrastructure. Then we have under our transport engineering department, there is one technical committee which actually deals with the standards on e-vehicles. And then there is a third technical committee with in the civil engineering department of BIS, which deals with the National Building Code of India, which is SP 7 2016. This code, it is a very prestigious publication which covers all aspects of planning, design, construction, and operation and maintenance of buildings and built environment. So in this code,
it's come. Okay. Shilpa has helped you. Go ahead. Thank you, Shilpa.
Shilpa, can you please? I think it has come
she
from my
has to run it now. Shilpa has just run it now.
It has come from her side only, sir.
It has come from my side only, sir. Just a second.
Okay.
So maybe you can do that full screen.
Yeah. Yes. I have done that also.
Yeah.
Yeah, please proceed.
Yeah. So.
Please proceed. Yeah.
So coming to the standards, as I said, we have these 3 technical committees. Now, the Electrotechnology and Mobility ETT 51 is the main committee, which has prepared the Indian standards for the electrotechnical aspects of totally or partly electrically propelled road vehicles. Total 19 standards have been published. Ms. Geeta Lakshmi also mentioned about the need of the standards on e-vehicle batteries infrastructure as well as on the interoperability. So I'm glad to mention that those standards have already been formulated. Electrotechnical IEC is the standards body at the international level. So we are also P members on that IEC committee, and the various standards formulated by the IEC are also being considered. We actually work in tandem with them. We have working groups who are participating on those technical committees, as well as we send comments on those documents which are being circulated by IEC. And after evolving consensus within our technical committees, these are some of the important standards on the electrical vehicle conductive charging system, which we have already formulated, including on AC charging system, DC charging system. So these are the various lists. I will always already be sharing my presentation, so will not go into the details of these standards. Then you can see there are standards for the road vehicle to vehicle grid communication interface. The IS 1017 is the key electrical vehicle charging standard in India. It provides the basic features of all electric vehicle charging systems. The part 2 talks about the electrical sockets, and the next is part 23, which describes the requirements for DC charging stations with power output of 50 kilowatt to 200 kilowatt. Coming to IS 15118 series, which is on the combined charging system. So the various requirements for a combined charging system where you have both AC and DC charging infrastructure. So those are covered by these series of standards. Regarding the digital communication, the need We also have standards IS 17017 part 24 covers this. Then recently we have also finalized an Indian standard, very important, which is the specification providing low DC power of less than 7 kilowatt for light EVs, which will be covered by IS 17017 part 25. Now, coming to the standards on the battery swap stations, we all know the need. It is going to support the circular economy by allowing recycling of batteries and the second life of usage. It is an economical proposition and enhances safety, particularly considering the high Indian summer temperature conditions. So, charging battery, it supports charging battery outside EV, enhances its safety. So, we have also come out with 2 standards, and the other standards are being prepared. They are already under wide circulation draft stage for public comments. So these standards are IS 17896 part 1 and IS 17896 part 2, which covers the general guidelines and the safety guidelines for the electric vehicle battery swap system. I already talked about the international standardization. We are actively participating, and these standards have also been taken into cognizance. Whereas when we talk about the charging infrastructure, we have slightly modified the IC standards considering our Indian conditions, the high temperature conditions, and then also the type of vehicles which are there in the country. For the plugs, socket outlets, and couplers, we have another IC committee, which is SC23H, on which also we are a PM membership, and we have a series of technical panels who are actively participating, and they also take into cognizance the standards formulated by this IC committee. Now coming to the very important in publication of BIS, I already talked about National Building Code of India. This is one document which has got the most adoption by the state, the urban local bodies, who are basically the regulating body for the buildings, for the land development and the building construction activity. Now, these local bodies, they basically gives reference to NBC Part 8, Section 2, which is for the electrical and allied installations for all electrical services. So it is particularly becomes very important to modify this particular code, which has been referred in all the regulations, all the development control regulations and the building bylaws of the local bodies. Now, presently, our technical panel was very, very visionary. So when in 2016 this standard, this code was published, at that time only we included one provision regarding the electric vehicle charging, so that the buildings which are coming up, they may have the provisioning for the electrical vehicle charging. At that moment of time, there was no other policy, regulation, or even Indian standard for the EVSE available. So therefore, we refer to the IC because we generally do not refer to any international standard, particularly in case of civil engineering fields. So we refer, however, here, understanding the need, we had referred IC 60364 part 7 of 2015, which basically covers requirements for special installations or locations for supplies for electrical vehicles. So this was referred in the NBC, and NBC had said that there should be adequate provisioning should be made for the e-vehicle charging in designated spaces for electric car parks and enclosed and covered car parking. So at that moment of time, this was the wisdom of the committee, that let us try to, because we only cover the buildings, not beyond buildings, and therefore when we come to buildings, so in group housing, in the basements, we need to provide where we generally have the car parking, we need to provide this kind of facility. So we also said that the distribution board and outlet should be protected and metered, and the concerned IC standard was given for the reference. Now, what has happened subsequent to the publication of the code? Even this IC standard has got revised, and in this standard basically applies to circuits intended to supply energy to electric vehicles and circuits intended for feeding back electricity from electric vehicles. So there is a need to look into this standard, and in case an indigenous standard based on this standard is required, so we also need to formulate such a standard. Now, in this slide, we have also talked about that what are the different various changes which has come from the previous version of IC 60364. I would also like to mention over here that this standard does not cover the assessment of the risk of explosion due to the possible protection of hydrogen or other flammable gases during the battery recharging phase, and the requirements for EV charging equipment for wireless power transfer are described in the IC 61980. So here I have tried to capture all the IC standards which may be relevant to us, or which a group of technical experts may look into, and may decide like what kind of provisions we can have for the built infrastructure. Then coming to the CE regulation, it is another body. We know that the supply of electricity comes under the concurrent list of the Constitution. So there are various authorities which are responsible for regulating this activity, from the DISCOMs to the State Electricity Regulatory Commission boards. And at this center, we have Ministry of Housing and Urban Affairs, the Ministry of Power, as well as Bureau of Energy Efficiency, which has been made the nodal agency by the Ministry of Power, and BIS, being the national standards body, has the critical role of making standards. So coming to CE regulations, another very major development. In 2019, they have come out with this Central Electricity Authority measures relating to safety and electricity supply amendment regulations 2019. So the original regulation is of 2010, and in 2019 they brought out an amendment particularly to cater to these EV infrastructure needs and the safety requirements. So it also gives reference to Central Electricity Authority technical standard for connectivity of the distributed generation resources regulations 2013. It defines EVAC, defines socket outlet, and then these are some of the general safety requirement of EV charging stations which have been covered. It has been said that from the finished, although it has been written finished ground level, however, I think it should be finished floor level. So the electrical vehicle charging point should not should be at least 800 millimeter above the finished ground level is one requirement which they have given. It also says that all such charging stations shall be designed, installed, tested, certified, inspected, and connected in accordance with the provisions of this chapter. Then it also says that the adapter shall not be used to connect a vehicle connector to a vehicle inlet. The electric vehicle parking place shall be such that the connection on the vehicle when parked for charging shall be within 5 meters. Why I have highlighted these points are that these are some of the provisions which needs to be incorporated in the building bylaws itself, so that these can be copiously implemented by because there is a need of which all of you will agree that there is a need of supporting and holding those people at the local body level, so that they can easily adopt these provisions from the CE regulations or from the guidelines of Ministry of Power.
Last 2 minutes, please.
Yes, I will quickly now.
2 minutes.
Important aspect, this CE regulation also covers earth protection system for charging stations, requirement to prevent fire for electric vehicle charging stations, testing of charging stations, and gives a lot of stress on inspection and periodic assessment of charging stations by the owner or the state electric inspector or chartered electric safety engineer.
Okay.
And the maintenance of records and the international standard for charging stations, they have also given reference to some of the standards, and have also talked about that when the EVs infrastructure is outside, then what kind of ingress protection code is to be complied with. Now coming to some of the advisories, guidelines, and policies. Ministry of Housing and Urban Affairs, you all must be knowing that the TCPO, Town and Country Planning Organization, under this ministry has brought out this model building bylaws of 2016, and there is one urban regional development plans formulation and implementation guideline, URDPFI 2014. Again, in 2019, they have amended MBBL and have also brought an amendment to URDPFI so as to define the provisioning for the number of such facilities like public charging stations or FCCs to be created in the at the local level. So these kind of guidelines and the model building bylaws, which basically covers two kind of structures. One is for it has basically classified the buildings into two types. One is residential buildings and has also covered the group housing and gives the requirements for the number of such infrastructure, as Suresh sir also mentioned about the 20% of the total vehicle load capacity should be such structures. That has come from the these MBBL guidelines which are here. And when I come to talk about the URDPFI, it also gives you the various provisions regarding the number of such amenities to be to be created at the local level, at the city or town level. Now, these need to be properly incorporated in NBC, although they have already circulated these to the local bodies. But the thing is, the concept note was not, I will not say, but it's a very good attempt has been made, but there are certain definitions, certain terminologies which have been used need to be, elaborated so that it's easy to understand and implement. And therefore, I suggest that there should be one strategic group which needs to be created under our CD46 panel, P1, which looks into development control rules and general building requirements, as well as one panel under the CD46 P13 for electrical and allied installations, which can look into all these provisions, policies, guidelines, and then come out with a crisp, lucid provision for implementation by the local bodies. Now,
Madhurima, you have to close now.
Yes, sir, just one more minute.
No,
sir.
because we got to have one more presentation.
Yes, sir, just last point, sir, regarding the Ministry of Power guidelines, because this is again a very important guideline which has got revised in 2022. Okay. So I want to bring this to the notice that 2022 guidelines have come, which is consolidated guideline, and it makes reference to all those Indian standards, IS 17017, which I talked about. The various kind of AC/DC charging systems have been referred in this new revised consolidated guidelines. So there is one NITI Aayog handbook also, which may also be looked into, which talks about preparation of EV charging infrastructure roadmap, assessment of EV charging requirements, location planning, arranging electricity supply, and models of on-ground implementation. So these are some of the policies, advisories, standards, which need to be looked into for coming out with the comprehensive lucid provisions for adoption of the local bodies. That's all from my side. Thank you. You can write.
Madhurima, that's quite a bit, and it's fantastic. I never knew that we got so many standards. 17017, wonderful number.
Yes.
And part 1 to part 24, 17896, 15118, and all the new parts, including the IEC, the revision on that, including all the work of the Ministry of Power, Ministry of Housing and Urban Affairs, and also the CEA. Wonderful information that you've gotten over there, and thank you very much. Now, this will bring us to the next particular session component, and that is going to be Vimal Kumar. What do we do with how do you go about? Now, CPWD is one of the biggest builders. Now, they are doing in a very large way. How do you do for new buildings that are on their drawing plans? Are you putting the electric charging there? What do you do for existing building? How do you go about? These are issues. It's applicable to all parts of the country. So let's hear from Vimal in his own inimitable way, trying to say his presentation. Please open up, Vimal, and make the presentation. Chief Engineer, CPWD, Vimal Kumarji. And an outstanding Chief Engineer, by the way. Go ahead.
Thank you, sir. Sir, good afternoon to all the participants. Greetings to all the esteemed members of forum, and special regards to Bhavani Prasad sir. Sir, actually, a few part of this has been covered already by Madhurima. So I will just
so you can leave out those areas.
Yes, sir. I will, while making presentation, I will leave, sir.
Yeah.
So I just want to start with saying that in our department also, based on the directives received from the government, we have already taken up efforts for providing large number of solar PV rooftop plants, as well as taking up the EV installations in the government buildings. Already we have issued instructions, and the field units are working on that. And I just will start the presentation bringing out the national statement by our Honorable Prime Minister at the Conference of Parties Summit in Glasgow in last year, sir, where the Panchamrit 5 nectar elements were stated by him, which are the commitments from our country: non-fossil energy capacity to 500 gigawatt by 2030, 50% of energy requirement from renewable by 2030, reduction of the total projected carbon emission by 1 billion tons till 2030, carbon intensity of economy to be reduced by 45% by 2030, and by 2070, India is targeting to become net zero. Now, in all these aspects, I think besides government doing large number of efforts in different sectors, manufacturing sector, you can say transportation, so many things, EV is a part of that, and it's an important part of that related to the transportation. I think this aspect has already been mentioned earlier. Now, the major role being played for the implementation of EV infrastructure is within the domain of Ministry of Power, who in collaboration with the Bureau of Energy Efficiency are working on it, and they had issued a letter to all the state governments and the central government departments, wherein it has been notified, instructions have been given, some standards have been mentioned. The objectives as defined there are enabling faster adoption of electrical vehicles, having a safer, reliable and accessible, affordable charging infrastructure and ecosystem, having affordable tariff also, chargeable from the charging station. I think special incentives are also there, cost to cost basis tariff provisions are there. In the process, there will be employment generation, income opportunities also for the small entrepreneurs. And the government wants to proactively support creation of EV charging systems. Besides this, the electrical distribution system has to be made prepared for adopting the EV charging system, and in the process, the security, energy security, and reduction of carbon intensity would be taken care of. Now, I think a few these things have already been covered by Madhurima.
She has covered this. She has covered this. Correct. You can leave it out.
Okay, sir. So this these instructions generally describe, have given the definitions also. Here you can read it. Participants can read, and here the things which are of importance as far as the infrastructure are the captive charging stations and the public charging stations. Now, any of the housing society or bus depot or individual government departments can go for their own captive charging stations also. Besides, of course, the public charging station provision is also covered there in a much larger detail. The guidelines, I will just read fast. Electric vehicles at their residence office, any individual can have. Individual is also, or the entity is free to set up a PCS, which is of course compliant to lay down standards and guidelines. As soon as any public charging station wants to go for it, they have to apply to the distribution company, and they have to release the connection for this. There are in fact timelines given also there, that within 7 days in metro, 15 days municipal area. Of course, this will be subject to availability of the infrastructure with the PCS intending firm. The guidelines provides that wherever required, the supply extension of distribution mains will also be taken up by the distribution licensee, and supply will be made available. And there is also a provision that any public charging station or chain of charging stations can obtain electricity from any generation company through open access also. Of course, the tariff also is such that they say that cost to cost basis it has to be given, so that there is it's like incentive. This just describes as to what the PCS public charging infrastructure will consist of: related substation equipment, civil works, electrical works, of course, adequate space for the charging entry exit of the vehicles, appropriate fire protection equipments. Public charging station shall also have any or more chargers. The charger configurations are coming subsequently. This in some way have been covered by Madhurima ji also. Charging stations shall be free to install any charger other than those prescribed in these norms also, depending upon their own requirements. There is also provision that the PCS will have a network service provider hooked up, so that the advanced remote online booking of charging slot by EV owners can be done, and such informations to the EV owners will also include location, the type of chargers installed, available service charges. In fact, if you see the Google also, you can already find some such information available. The public charging infrastructure will share the charging station data with the state nodal and central nodal agency. Central nodal agency is Bureau of Energy Efficiency for this purpose, and they will also comply with the provisions as already elaborated by Madhurima ji, which are covered in Central Electricity Authority notification. Of course, this also says that all the equipment will be type tested by any of the agency lab accredited by NABL from time to time, and the minimum infrastructure requirement as stated above may not apply to private charging point for self-use. Captive charging infrastructure for 100% internal use of a company for its own lease fleet for its own use will not require required to install chargers as per para 3, means whatever I have described earlier, means for the captive power generation, you can have your own requirements and a setup. The public charging station may also be installed by the housing societies. So even if the housing society on its own can also install, or they can also make arrangement with third party to have this services provided, wherein they can give them space and the other entity can take over the space and provide the services. The database will be managed by the Bureau of Energy Efficiency. They will create and maintain a national online database. They will also create a web portal. These are the provisions which are already elaborated in the Ministry of Power letter to all the authorities. The tariff also has already said that the single part, it will be single part tariff and it will not exceed the average cost of supply. And this is applicable till 31st of March 2025. And in the domestic consumption, the same charges will apply. It also suggests that if you are going for public charging system, then there will be a separate metering for the consumption to be recorded and billed. And the discoms can also, there is some provision wherein they can also have the leverage on funding also under this scheme. So the government is giving some incentives and trying to provide opportunity for its rapid expansion. This is already also covered in the Ministry of Power letter, and it also provides the type of charge connectors, like as you can see, fast charger, slow and moderate charger, AC, DC. These all provides as to what type of connector, voltages, number of connectors. So these guidelines are available for different type of vehicles, two-wheelers, three-wheelers, four-wheelers. So this part is already covered by Madhurima ji, so covering the for different type of EV charging infrastructure, what will be the applicable codes or the IS. I'm just skipping. This Central Electricity Authority's notification mainly relates to safety provisions for electric charging system. This has already been covered by Madhurima ji. So of course it covers different aspects related to as to how the infrastructure has to be provided, what are the safety guidelines, what are the lightning conduction protection to be taken up, what are the fire prevention measures to be taken, and different guidelines are given. I'm just trying to go through that. It also talks about discrimination in the power distribution for the residual current device, so that there is while tripping there is a sort of a intelligent decision as to which part has to trip. And here I would like to say that a separate circuit has to be given for the EV charging infrastructure, rather each of the equipment. And in fact, it will be still better if the combined system as a whole is provided with the separate substation, particularly the large PCS. And of course, it talks about the earth conductor also, earthing also. These are to prevent fire. It says firefighting for system for charging station will be provided in accordance with these regulations. And it also says that enclosure of the charging station will also be made of fire retardant material. Of course, wherever these systems are installed, they will be provided with fire alarm detection, alarm and control system. And it also specifies about the power supply cables. The testing of the charging station, it also stipulates as to what insulation resistance. It gives reference to IEC standards. And it also says that all the owners have to ensure the compliance. Now, the inspection and periodic assessment of charging station, we're covering next slide. I think part of this is already covered by Madhurima ji. International standards as relevant are also mentioned herein. Now, again, this part is also covered by...
Yeah, model building bylaw covered already.
Here, I only want to add one thing, that model building bylaws as our Housing and Urban Affairs, basically they are model building bylaws. Until and unless they are adopted by the local authorities or the local bodies, they don't become sort of enforceable. So the government is also trying to take up the matter with respect to state governments and the local bodies to make it mandatory to provide such type of services. So norms are being worked out, and until unless it is implemented at the ground level, I think the things will not be sort of in a positive direction. So government is working on this. Model building bylaws are there, and we expect that these will be adopted by the local bodies also. These are also the part of the model building bylaws. So now preparing for the new buildings. As to how we have to go about it, of course, this describes to what will be the typical infrastructure. Power supply has to be taken from the supply agency, and we have to create our feeders, and feeders being supplied to different type of chargers, and having a mechanism to ensure accounting, billing, booking, etc. So the first and foremost point which is applicable in new building would be what are the local building bylaws. Suppose something is enforced by the government, people will be sort of bound to provide that. So as such, no such bylaws are there. Of course, it may be there by some state governments, which can be checked. Second is the client's requirement. Sooner or later, everybody knows that we are going for EV vehicles, so client also will like to have implementation of this. So once you go for a big new building project, you have to ensure that the parking guidelines are there, ECS for what we call. Among them, some percentage will have to be earmarked for the EV charging vehicle. Of course, proper entry and exit of these vehicles, as already elaborated earlier also, we should not have it on too much of below basement things, so that to avoid flood prone area. We have to take care of the power supply requirements. Substation has to be designed, taking into the load. In fact, the model building bylaw says whatever is a load calculation, take 25% extra as a safety factor. So 1.25 is the safety factor for that. You have to think of online networking. Nowadays, provision of IoT-based apps are there, which can be used for booking, billing, accounting and all that. Of course, in the new building, fire alarm and firefighting provisions will be applicable. As Madhurima ji is already working on the National Building Code, whatever comes out from there will also be applicable in this case.
Vimalji, 2 minutes to wind up.
Okay, so existing building, it is same, sir. Sir, existing building, it is also the same issues. Of course, the bylaws are as of now are not there, but the government's initiative is there. So we are already asking people to provide this. We have started with the some sort of a minimal arrangement. All aspects we have already, as indicated herein, are similar to the new building aspect. So people are taking our government field units are taking efforts into that, and we are going to provide this. Anybody who wants to provide this in new existing building will have to take care of this. There was another topic as to how the real estate will mention. So real estate for the new projects will be covered by the bylaws, covered by the client's requirement already discussed. Suppose the existing building are there, as I have discussed earlier also, they can think of having a tie-up with some agency wherein the land can be given. There is something which we call as ESCO mode, wherein the company invests the amount, and there is a revenue sharing model which can be implemented. Of course, the other aspect I already mentioned. So in operating such type of systems, you will need to have a staff for maintenance operation. Another aspect of harmonics and power factor distortion is also there. So first and foremost, whatever the guidelines are there with respect to the standards of the individual equipment and the CA guidelines, if implemented, will take care of the site installations. Of course, during discussion with manufacturers, we found that it is preferable to have a totally separate distribution scheme for the EV charging system, have a separate earthing, which will help. And as far as the OEMs are concerned, they are designing the EV charging equipments with the THD less than 5% and power factor more than 0.98%. Meter and billing, this I already described, that there are nowadays the norms which are applicable. The QR code, OTP, RFID card based, app server based online payment systems are available, which can be used. IoT based applications which are there can be useful in booking, identifying the locations, identifying the infrastructure available, and you can book the slot, go. And it's applicable for billing, etc., for online payment also. Of course, for maintenance, you will need to have a manpower. For the EV charging systems, you will have to have a tie-up with the manufacturer who has supplied the equipment to have a comprehensive maintenance or on a paid basis maintenance. Then you have to have a third-party tie-up with the IoT-based app services who will be providing you the services for the booking, billing, accounting, etc. And you have to also have a tie-up with the supply agency. This maintenance also, this is a part of the CEA notification, which says that owner of the charging station will keep records in regards to the design construction. The owner of the charging station will keep record of the test certificate. They will keep the records of the results of every inspections, testing, and periodic assessment. And also the owner of the charging station will retain copy of all the records as specified in the sub-regulation. So the maintenance of the infrastructure will be covered under these guidelines. And testing and certification provision is also there. It will be tested and inspected by the owner or the electric inspector or the chartered electrical safety before energization. And thereafter, every year, this sort of inspection has to be done for the initial 3 years and thereafter every 4 years. They will establish and implement a safety assessment program for regular periodic assessment. I think that covers my presentation. Thank you.
Wonderful, Vimal. Everybody on behalf, everybody, you are the one giving actually what needs to be done on the ground in all buildings on the drawing board and to come into construction. Number two, and all those things, the existing building, how can do that? So you got brought in. Very interesting, Ali. All you wonderful speakers, Shanti, Geeta Lakshmi, as well as Rashi and Madhurima and Vimal, you brought in so much amount of value on different dimensions of it. I don't know how to thank. I know I would have liked to give each other much more time. We should have given maybe 30 minutes to each other, but we gave only 12 to 15 minutes. But I'm happy we got a lot of questions generated on that. With the permission of the host, that is Daruwala ji, which I taken directly. I already have around 12 structured questions, including chat observation. I'm going to seek that time of...
Sir, before that, I have raised a hand. I want to add one thing which is very important, that India is the first country to have an indigenous BMS standard, IS 17387 of 2020.
Yeah.
We are the first country globally to have this.
Very good. Thank you so much. I'm sure you will open up. There are many things coming to you. We got 12 odd questions there. With your permission, sir, I won't take more than 12 minutes, 1 minute for each question and the answer. Answers are going to be very, very sharp. You don't have to go into details over there. And if you can do that, it'll be fantastic. Sanjay Narayan is the first one to raise a question at 11:11. And he says, we are fast, the EV batteries lose their retention capacities. You may also know that 2000 moving parts in an IC are not charged ideally. Therefore, what they're trying to see is, how do you take care of this? I think the right one, and especially in the grid, when you take the particular power, there are losses. He says more in the T&D losses. It's a question both can take the particular on Shanti also, because T&D losses coming. These are the loss that's coming in the battery itself. So it's a larger macro issue of the transmission distribution loss. That's your Shanti. And the other one is the loss that's coming in that. So first, if you can take it for the first 30 seconds, then I'll ask Rashi to take the second one, retention. Please go ahead.
Yeah. Like as I was mentioning also, like, yes, this EV is definitely going to be a stress on the grid network. And definitely this is also going to be an additional loss because of the power it is going to draw. But my suggestion is that, I mean, also the recommendation is that we should go for more distributed generation so that we don't put a stress on the transmission itself, so that we have sources at the load center itself. That's what we mean by distributed generation. So like a prosumer concept, we are all aware that we should have more generation at the load end itself, so that the power does not have to flow from a far off, say a few 100 odd kilometers, or even that to say hundreds of meters away also. We can have it at the local premises. That would definitely help in overcoming this challenge.
Yeah, very good. I think before I ask Rashi to question on the retention one, I want Geeta to talk on issue related to sag and swell, because also a related issue on that, the whole distribution one. Geeta, you want to add maybe 10 seconds?
Yes,
sag and swell?
Yes. The same as what continue to what Madam has said.
You are not on the video?
Yes.
Yeah, go ahead.
This can be very well attended by increasing the renewable share, and as well as when we implement this discounted tariff. So what happens? The peak demand can be reduced. So basically, the fag and swell is because of the peak demand. So this can be attended.
Rashi, retention power, batteries. Somebody is doubting it.
There is absolutely no issue on the retention power of the batteries. The efficiency of the battery is close to 95 to 96%. And if you are correctly charging your batteries, you will not have a retention problem of the capacity. And when you come to an end of life, like I said earlier also, you have to go for a reuse and recycling. Both the standards are already in process and they should be out within 6 to 8 months.
Thank you so much. We got Vinod raising two questions, one at 11:54 and another 59. Both, one of them is related. Just know the point that is there, with a lot of power supply problem being there, if EV vehicles use is increased there. But I think good answer came in from when Shanti gave it, only 4% would be the additional load even by 2025. That's a message she gave that's very heartwarming. So his question is primarily on that. Do you think it can be done? They can produce the additional power required to deal with the EV. So, Shanti, take it first. You are mute, Shanti. Unmute now. Thank you.
It's an extension of the same question, sir. My answer was more or less would be the same. And also, we might have also heard about microgrids, where, where remote areas, there was one question probably related to the location of the load itself, like remote areas, how do we power them? So definitely microgrids is a good solution. Microgrids with renewable generation as well as the battery storage.
Okay, yeah, please. Rashi wants to add something there. I find she's raised.
I want to just take an extension of what Shanti ji said is that, see, microgrids need not be only for remote location. They can be also for urban and rural locations to reduce the burden on the grid, have localized generation. We have to have a hybrid combination where you have large-scale storages and large-scale renewable energy generation plants and small-scale and small distributed renewable energy plants, including...
Brilliant. Thank you. Second question is, of course, whether any government regulation in India on e-vehicle has been done for charging procedure. I think Madhurima can take the first 30 seconds, second 30 seconds with Vimal. Government's preparedness to push through this. Madhurima? Whether any government regulation in India for EV vehicles usage and charging procedure in domestic power grids and private grids. So you take the first one.
I'm not sure about any such regulation. Maybe Vimal Kumar sir would like to add regarding this.
Okay, you think in an operative regulation for mandatory is not come. Okay, Vimal also said the same thing.
I agree there. But at the same time, I would like to add that the government is very keen and is taking a lot of steps and giving directions for earliest possible implementation, issue of guidelines and sort of mandatory regulations for this.
I think Darwala, I'm going to ask Darwalaji because he's a practitioner, into the building regulations, because that's what finally people, unless you put it in that particular thing, they won't put in the building so many EV vehicle space. Even the Ministry of Environment Forest ensures the approvals are given only based on that. Darwala, do you want to add something on how to make that happen in the regulations to make it mandatory?
We'll have to take a very comprehensive view because, as of now, we don't know how it is going to proliferate. So depending on that, we'll have to take a call whether we should have regulation and then and restrict the numbers coming in over there.
Okay, thank you. It's a comprehensive issue. I got the point. Roshni Yehuda, my good friend, she has raised a question that she wants to ask Shanti, how would EVs help towards net zero, as they will be basically shifting the CO2 emissions from one point to the other. So she is a little doubtful on by going for this particular thing, are we really reducing the carbon dioxide? It's a wonderful question. I have also some answer to give Roshni, but let's hear from you. She wants to hear from you.
Yes, sir, definitely. And we all know this. First step is electrification. If we don't even electrify, then how do we send them from renewable sources? First step is, of course, electrification. Then there's no point in burning fossil fuels to generate that electricity, which I will be using for my EVs. Definitely, it has to be from renewable sources. So that is ultimate. We are seeing obviously
not the grid through fossil energy, but through renewable. That's the point.
That. And also, we all know that the pace at which we are going for renewable renewable is embracing or capturing the overall energy domain. In power sector, we know that it's more than 40 gigawatt of solar itself. So definitely, we have an ambitious target in India of reaching that. So we are all that is the direction going forward.
Okay. Very good. Next question. You have not identified the name. anonymous attendee, and they talked into the electrical future rate increases for tariff. I think partly the good answer came in from Vimal of trying to say that by 2025, no change to happen on the energy. Would you like to open up, Vimal?
Pardon, sir, say it again, sir.
The rate, electricity tariff.
Yeah, sir,
There's
actually,
a doubt that tariff will increase because of this. So
no,
you
no,
gave
no,
an answer.
Sir, the guidelines which have been issued by the Ministry of Power rather says that it is on the average cost basis, supply average cost basis has to be charged. And in fact, there is a revenue sharing model also to enhance these early installations wherein they suppose the government's land or government's land can be given to the government infrastructure being installed, even the private infrastructure being installed, wherein 1 rupees per unit can be given to the person who is installing. So revenue sharing model is also there. And the tariff, it already says that it has to be based on the average cost of supply.
And
so,
not to increase it, in 2025.
Yes, sir, and not to increase for the next 3 years.
That's what I said. That's what I said. Thank you very much. Dr. Deepak Mashelkar, sir, one of the outstanding persons in the sector. He has asked 2-3 questions on that. Charging stations and parking slots for office building, fast DC chargers so that charging at not peak hours. Of course, this was briefly touched on even by Darwalaji, timing on that. Housing societies to have AC chargers in assigned parking and DC fast chargers in visitors parking in some location there. Would you like to take this, Rashi, and then before I give it to Geeta?
Sure,
You got the question, Dr. Mashelkar's question, Deepak Mashelkar's question. 3 questions.
1 second.
Charging stations in parking slots and office building. Fast DC chargers so that charging at not peak hours. And then he's also said housing societies have AC chargers. So he has got a clear differentiation between residential societies and the office building. And that's a very crucial input, according to me, which Deepak has brought onto the table. And your view on that?
So what happens is, you see DC charging as of today. I mean, this is my comment as of today. What happens is your battery life is affected if you continuously do a DC fast charging. Now that really depends on what kind of battery pack is available in your vehicle. Now what happens? Now the current vehicles that are available, they will be all preferably, even off the record, everybody will say go for a slow charging.
Okay.
So what we need to understand is we need to have a mixture of AC and DC chargers together to get to the optimum life of the battery and to get the best value out of your vehicle.
But would it be economically viable to put that in residential societies?
Residential societies, you can go for a small AC charger.
That's what he suggested.
Yeah, that is enough.
Geeta, you want to add anything?
Yes, I agree with the suggestion that AC chargers should be in the residential society, but the one more point he has mentioned was DC for the visitors, because if you see the visitors come for a smaller time and they expect a quick charging. So that what he said is absolutely right. So have AC for the residents and DC for the visitors.
Oh, that's another twist on that.
Vehicles. Comment on this.
Okay.
I would also like to add in, sir.
How does the society keep differentiating between who is going to use the AC
I know. You got to be practical there. So let's push on to the next question. Are there any research and development on solar vehicle sector? Please share your comments. Who would like to take that? Solar vehicle. Yeah, Rashi, go ahead.
See, so there is a lot of research being going on into how you can integrate solar energy to the vehicles. Now, the first and the foremost and the most easiest and the low-hanging fruit is have your energy source green through renewables, whether it is solar or it is wind. That is the first easiest way. The second is to integrate your renewable energy panels into the vehicle, whether it is a 3-wheeler, it is a car, or it is a truck or a bus. Then there is also by way of pantograph charging, which again would come through the renewable sources. So all of this will include into the contribution into the energy sector of renewable energy.
Okay, thank you. Thank you on that. Mr. Jain has got a very interesting question, MK Jain. And what is because you use the word BMS. To all of us, working in the sector and built environment. BMS is building management system, and whole amount of work is. But I got a new meaning for BMS, which is battery management system. Rashi has told that. Of course, he must be mentioning about that. And we find Madhurima as the word BAS, BAAS, as the one. So whether it is BMS or battery management service or BAAS, whatever. I think the question is that the main problem is with the battery module, where cell vents are blocked, and BMS is also tightly packed with it, and there is standard for making module an intelligent BMS. Why is a cell certified under 16046? That's an Indian standard. Madhurima can join there after Rashi. And the other one is 1893, which is for EVs. So we have two. One is cell through 16046, and the electric vehicle in 16893. The issue is the BMS issue. Would you like to open out on that? It's a little long, complicated question, not direct answer, but even then, throw some light on it briefly.
So who has asked this question, and is it there in the question answer session, in the question answer Q&A box?
Yeah, it was there. It is there in that. Anyway, you want to add something on the battery management system? This issue between different on the venting. This question is on venting. Venting, VENTING. Okay, leave it at that. Madhurima, you want to add something? Two standards are mentioned.
I can't.
So, actually, I would just like to add over here that the CA regulations, the Ministry of Power guidelines, it talks about that the certification has to be done by NABL accredited agencies. That is one aspect which I am aware of for such service providers.
Yeah. Okay, anyway, I now got a satisfactory answer to this question from MK Jain. We'll take it, we'll study it and give detailed reply on that. Sushant, we got three more questions. Hello. I already taken the extra time I sought from, I got three more questions. Let's finish that. Don't waste time on a thing on it. We don't have full answers on that. Sushant Baswan, we need to know for battery swappable standard for two-wheeler, which will be uniform. That's a question. As of now, EVs charging cannot be unattended. It should be manned activity. So two things are covered in Sushant's question. Would you like to answer? One of you?
So, sir, in the battery swappable systems, three standards have already come in IS 17896 for the general requirements, safety and others. But for the light EVs and high EVs, the standards are already under wide circulation at the public commenting stage.
Wonderful. Thank you. The last question, because both are combined here. I raised two questions, 1 and 2, you answered both of them. Rohit Sardesai wants to know, currently various local bylaws ask for 30% parking. I'm glad, because everybody felt nobody is asking for that. So he has an answer. Somebody said in some local body, all with 30. Minimum is 20% is what we are insisting on. It's good to hear that, that somebody where Sardesai is operating is already asked for 30%, whereas currently charging station is community charging bases, which requires extra parking base, which do not have any provision. Moreover, having 7.2 kW chargers for individual apartment unit is not practical, as individual meter is normally 5 kW, very important aspect. So this particular thing can be a separate meter to deal for all the whole society and not individual meters, and also tariff different. So very nice question by Rohit, a very practical question. Who would like to take it? Vimal can take it, or Rashi can take it, or who can take it?
Sir, I can take it, sir.
Go ahead.
Actually, sir, if we talk about individual plotted housing, then this problem may be there. But once we go for a group housing, there has to be a separate meter, or there has to be a separate agency running that that charging mechanism or charging infrastructure. And in that case, it will be got covered under PCS.
Vimal, even in that case, where the charging is some other location, whereas your housing unit, however, each one has a meter on its own, depending on the current consumption you have, and normally those particular meters are 5 kW1. That's the point that he's trying to bring it. Unless Bhavani Prasad, you want to add something on that? Do you think you can, is an issue on which we can give some good answer? So good question, very good question according to you. One of the best today. Because that's a practical issue. You are living in a house there. I use the power for lighting, power thing, and charging is separately down in the basement or somewhere. And that particular thing can
Where from has this 5 kilowatt limit has
Is
come?
separate. So that's the
That's
point
the
that he's
question.
trying to say. The separate,
And
not your residential unit. Yes, sir. Bhavani Prasad ji,
where from
you
this
want to
5
answer it?
kilowatt limit has come?
Sir, there are
And even if
separate
the 5
EV
kilowatt limit
meters.
is there and the charging is limited to 5 kilowatt, the battery can be charged partially at the reduced rate. It need not be 7.
And
There
then
are
there is
multiple
Okay, Rashi, you want to say
operating
something?
solutions for it.
Okay, Rashi, you want to
Sir,
say
see, the
something?
residential meters are different. The EV meters and the
Meters are
EV
different.
tariff is different. Each car, so even if your car is at the basement, you have to get a separate EV charging line from the discom, which is a separate
Very
meter.
good. So that's exactly the question. It should be separate. And that's also brought out partially by Vimal also. Okay.
Sir.
It is already
I thought everything is
And
over.
sir, I want to add, sir, even if there is some limit, then 3 kilowatt chargers are also available, which can be used by individuals.
Yeah. Okay. Thank you. I thought everything is over. Raddeep was the last question. I find 3 questions have popped up just now. Suddenly, again, Sanjay Sharan and Faslullah Syed and Setunath Mukundan. Very briefly to tell about, are we talking about a change happening? Suddenly change over from one to another? Shouldn't we wait and watch and do that? Is the crux of Sanjay's comments on that. And that's first one. Faslullah Syed is during the remote travel, how much time does it take to recharge a single battery? The time taken for charging is an issue being brought in there. And the last one by Setunath Mukundan, which has just recently come now, is there R&D happening in providing battery swapping at the charging station to minimize the time? Okay. So all the 3 questions are raised now by 3. Whomsoever wants to reply can reply first.
Battery swapping, very, very crucial. And yes, we are trying to standardize batteries across OEMs so that the consumers are not going to have any challenge, including the connectors under the battery swapping system. Also, we are trying to limit the load onto the grid by doing battery swapping so that the charging can happen at off-peak hours.
Okay.
And the consumer gets the complete value out of the battery charging. And it will be a lightweight model that is being looked out.
And how much time? How much time for recharging? Faslullah.
That is not the concern of the.
No, even he's asking a question. It's not his concern.
Anyway.
He's worried how long I have to put it on charging. It's a question.
Battery swapping, he does not have to worry about it.
He doesn't have to worry. So I'll tell him that. Okay, having told all this, Rohit says that even though you're given an answer, you cannot get separate EV meter for individual flats.
No, you
says.
can get it. It's
You can
absolutely
get it.
available. Which state are
Okay.
you in? If you're having a problem, please connect to the DISCOM
So,
authorities. If you still have a
misinformation.
problem, reach out to me on
Yeah.
LinkedIn. I'll help you.
Okay. Misinformation, disinformation, lack of information is not the right information. It is possible. It's being done. Thank you. So, ladies and gentlemen, I'm closing otherwise questions will keep on popping up. So, we got to be thankful for Daruwalaji for giving that extra time. I sorted 12 minutes, but I've taken more than 24 minutes. Very sad. But that's what happens when you're such brilliant panelists to give replies to the question. Thank you very much for each one of your wonderful presentations. Shanti ji, Geeta Lakshmi ji, Madhurima ji, and Rashi Gupta ji, and got so much energy also in the one. And of course, Vimal Kumar in practical application related one. And to all the panelists, I want to thank all the people who raised the question, and the response we are given is good also. And to Daruwala ji as well as Bhavani Prasad ji to do the particular. I'm sure the last word will come with the Daruwala ji. With this, I close the session.
Mr. Suresh, you did a fantastic job. I don't know how you're getting the energies to manage all this thing, as well as have a conduct of
these young ones are giving all the energy. Look at the way they respond, like this stuff.
I salute you, sir. I salute you. Thank you. Very interesting. Believe me, this turned out to be one of the best webinar I have conducted so far.
I agree.
It's really scintillating, and it has brought out more juice from each panel member than what I anticipated.
Juice is the right word.
Geeta Lakshmi ji, Rashi Gupta ji, Madhuri ji, and Vimal Kumar ji. Excellent presentation, and I am sure everybody, in the question answer, many of them have requested your presentation to be put. So I think we can be in touch with Shilpa, and she'll manage to put the presentation here. So whoever wants the presentation can get it. I would also like to have a presentation, especially of Dr.
And these questions where only one question may not give full answer, maybe we can circulate.
I have answered that question in the chat box.
No, you have. You have. I'll have a look at that. If I do that, I can't be doing what I did just now. to give 1, 2, 3 for all the questions, right from 11:15 onwards. Okay.
But people can still take the questions offline. I mean, my email ID is there. The ID is there. You send the
No,
question.
yours is already brought out, sir. As the host of the program,
We'll get
your
it.
name is already put over there.
We'll get
Okay.
in touch with the panelists and we'll revert back. Thank you very much. Excellent. We are overshot by almost half an hour. But nevertheless, it was time very well spent. Very well spent. I thank everybody, including Dominic and Shilpa, in helping us organize it, together with Mr. Bhavani Prasad and all my co-members.
Dominic in particular, thank you. Shilpa also, thank you. In fact, if I have been able to put all the questions one after another, Shilpa has been continuously taking each question as and when it happens, she pops up. So I have a WhatsApp 1, 2, 3, 4, 12 questions coming. I could not have done that if she had not helped me in that particular one. That's why what comes on the Q&A and the chat box comes onto my system immediately. Thank you. Thank you.
I now request Rumi to propose a vote of thanks. Rumi, please come.
The whole thing was done by Rumi. Rumi is the one who structured the whole program. Rumi, you should be very happy, man. Would you give in a 10-point scale, how much you will get? 7, 8 or 9? How much you will give for that? Rumi, from what you wanted and what you got?
Yeah, I would say 9 out of 10.
9. Good.
Perfection
9 out of 10. Fantastic. 9 out of 10 is a fantastic score.
And good afternoon to all. I would say well begun is half done. This is the first of the program which we are starting in the series. Myself, Rumi Engineer, it has been a pleasure and privilege to be associated with Focus, Electrical Vehicle at Mumbai chapter. Immensely thankful to our young, dynamic, energetic Suresh sir, who has been really moderating the session, keeping the time, keeping everybody on the toes, very thought-provoking questions have been asked. It was really good. Let me extend my thanks to Electrical Vertical Committee, our chair, Bhavani Prasad ji, co-chair Daruwala ji, Virendra ji, and Ms. Jayalakshmi ji, who have been instrumental in giving the form and shape to this event. My heartfelt thanks to esteemed panelists, Vimal Kumar ji, Madhurama ji, Shanti ji, Geeta Lakshmi ji, and Dr. Rashi ji for their valuable contribution by way of sharing their knowledge and experience towards the EV and its ecosystem. It has been truly an enriching experience, enlightening us on the EV, nuances of the EV, which has evinced a lot of interest amongst the masses and gathered a lot of traction in the industry. Highly appreciate Mr. Dominic and Ms. Shilpa's efforts, untiring efforts, I would say, and valuable contribution, unstinted support towards making this event a grand success. Finally, to conclude, let me express my gratitude to all the esteemed delegates for their participation and contribution by a lot of questions and chat. It was really engaging to see right at the end, everybody was really engaged towards this event. So with that, I conclude. Have a great weekend. Thank you, all of you.
Thank you.
Thank you. So I officially close this session. Thank you, all the participants.
Thank you. Daruwalaji, one minute, one observation. I don't think information on this topic in the overall public domain, while each one the car manufacturer have, but as far as users of the car is concerned, I don't think the 5 presentations itself brought in so much amount of thing. It'll be good if we can put it together as a document from Focus and give it. Of course, the right recognition to each one of the presenters will be coming on that. It'd be good to put an electronic version on behalf of Focus to do that. Please do that. I'm sure they'll all appreciate that.
Thank you, sir. Thank you very much. So with this, while thanking everybody who has made this webinar a great success, I thank you, everybody. Thank you very much. And I officially close this webinar now. Thank you very much.
Thank you very much.
Have a great and safe weekend.